All right. Good morning and welcome again to the second day of the California Plant and Soil Conference. My name is Khalid Bali. I'm irrigation specialist based at the UC Kearney Ag Center. And I want to express my sincere appreciation to the ANR Program Support Unit, Sherry and Rachel, for doing a great job keeping us on time. You know, yesterday we had two great sessions about remote sensing and automation in agriculture. And today we're going to get into the third session, which will make a great fit using the information that we learned from yesterday. Our first speaker today is Daniele Zakaria from UC Davis, and he will be talking about updating crop water use on pistachio under saline and non-saline conditions in the Central Valley. Daniele, the floor is yours.
Thank you, Khaled, and good morning, everyone. I was asked to give a presentation on present the finding of a field research study that we conducted in the last few years that was aimed to update the water use information on mature micro-irrigated pistachio orchard grown with on non-saline and increasingly saline soil. Now, to give you a little bit of a background information, as you might know, California produces about 99% of the US pistachio and about 30% of the worldwide pistachio. And it's a growing industry. In 2018, we basically had, according to CDFA and the National Statistics Service, we had about 270,000 bearing acres of pistachio and about 100,000 to 150,000 on non-bearing acreage. And in 2018, the production was approaching 1 billion pounds for an economic value of $2.6 billion. So it's a big industry and it's also growing. And in fact, with respect to the 2017, there was about 70% increase in value. Here is a map of the pistachio acreage on the left, masking all the other crops, and you can see is spread pretty well throughout the Central Valley, Sacramento and the San Joaquin Valley. However, most of the production, most of the acreage in California is located in the southern part of the valley in the county of Madera, Fresno, Kings, Tulare, and Kern. And Kern County alone has about 42% of the California pistachio production. In the last 20 years, pistachio expanded quite a bit on marginal soil. So those are grounds that are either saline or saline sodic and are not very suited for hosting other crops. And we're talking here for this area of expansion on the western side of the San Joaquin River. So basically in the westlands. And according to some estimates, these marginal soils now host about 20 to 25% of the total pistachio acreage. Unfortunately, this marginal soils and this marginal production areas also rely on either limited or impaired water supply. On the right side, you can see a map of the groundwater level change between 2011 and 2017, and you can see those areas in red are area where the basically the groundwater level was declined in the last few years, and those are the area where SGMA, the Sustainable Groundwater Management Act, will impose severe water limitation. Those are the areas where, you know, there's a lot of room for expansion for pistachio acreage. However, when we started in 2015, around 2015 with this project, there was kind of a very little information available to growers, to pistachio growers, on ET, on evapotranspiration and crop coefficient on pistachio grown with micro-irrigation system on non-saline and salt-affected soil. So we started actually in 2015, but the real data collection, the reliable data collection was conducted between 2016 and 2019. And we targeted several orchards located in the San Joaquin Valley that we classify as non-saline, S0, you can see here, then low saline, medium saline, and high saline. And those orchards were chosen in agreement with the Pistachio Research Board in order to be representative of the different growing condition and pistachio production in the valley. Our objectives in this project was to measure actual evapotranspiration and determine the crop coefficient values for this well-watered micro-irrigated pistachio. And also we wanted to determine, to understand the effect of soil water salinity on the tree canopy growth and on ET and crop coefficient, and also on the nut production. The funding program that we used was a combination of grants, research grants from the Pistachio Research Board and CDFA specialty crop block program. In total, we leveraged about $600,000 that we use for this research activities. Now, as I mentioned, the study orchard that we targeted were pretty spread in the southern part of the San Joaquin Valley. We targeted three orchards that were non-saline in the area of Hanford, and one orchard that was salt affected, but within this orchard, we were able to see a lot of spatial variability and a lot of increasing value of salinity. In this saline orchard that was located in the area of Lemoore, and in the non-saline, we basically captured 4 years of data, and so this corresponds to 2 biannual cycles given the alternate bearing behavior of pistachio. And then in 2018, we targeted another study orchard in the area of Coalinga on the western side of the valley. It's a little bit higher elevation and is now somehow in the valley floor, and we were able to target 1 biannual cycle, so 2 actually crop season. All the orchards were on Kerman variety grafted on Pioneer Gold 1 rootstock, and this combination represents about 80% of the pistachio acreage in California. Now, the hypothesis that we want to test was this: basically, soil water salinity lower the soil osmotic potential, and it reduced the ability of trees to extract and uptake and use water from the soil, and reduces the actual evapotranspiration on the trees, and as a result, reduces the nut yield. And of course, this has a kind of a rippling effect on the growth of the trees, because the trees are not able to fix a lot of carbon because of the limited extraction of water and nutrient, and lower canopy coverage tree intercept less radiation. And so there's a kind of a interaction of all this factor, and we were able to identify a soil osmotic effect, and also a kind of a energetic effect that was justifying the reduction of the crop evapotranspiration. Here's a few indication, a few information about the different study sites. We had a non-saline with the EC about 2 decisiemens per meter, ECE, and FPAR is the fraction of photosynthetically active radiation that it's basically a proxy of the canopy coverage. As you can see, as the salinity level increases, then we have a smaller trees with the, that probably will intercept less solar radiation. As I mentioned, the non-saline were located in Hanford. Our control orchard was located in Hanford, and the increasingly saline were in the western side of the valley. The activities that we conducted in during the research project, so basically we measured ET in all orchard, and then we determined the crop coefficient values with different time steps, and we try to capture the differences in evapotranspiration, in actual evapotranspiration among the different study orchard, but also within the orchard if there was a lot of spatial variability that were corresponding to the increasing level of salinity and sodicity within the salt-affected orchard. We also measured on multiple dates the PAR light interception, the photosynthetically active light interception, using the UC mu light bar that is operated by the Bruce Lampinen lab at UC Davis. We also capture some high resolution multispectral and thermal infrared imagery with the airborne platform in order to trying to understand if a lot of these processes can be somehow determined using remote sensing. We did this with the high resolution airborne platform, but some of the imagery acquisition was also done on dates and timing correspond with the satellite overpasses. And the idea was to somehow determine some vegetation indices on this imagery, and also get a sense of the canopy temperature and canopy temperatures variability within the orchard. We also monitor the plant water status in different way with midday stem water potential. We also monitor the canopy temperature with infrared thermometers, and also we got a sense of the trunk swelling and shrinking using dendrometers. We also monitor the soil moisture with watermarks, tensiometer, and on a periodic basis we also did some measurement with neutron probe scattering techniques. Also, with the help of the US Salinity Lab in Riverside, we conducted a survey with the electromagnetic induction technique in order to understand and quantify the electrical conductivity. And this was basically aimed to characterize the relationship between soil water salinity, canopy coverage, and actual ET and crop coefficient. And at the end of the crop season, we collected also yield, not quality data that was analyzed with a certified lab. The method that we use to determine the actual evapotranspiration is an energy balance approach, given that ET is basically an energy-driven process. We quantify the amount of energy used to evaporate and transpire water by difference by measuring the net radiation, the sensible heat flux, and the ground heat flux. And those measurements were done with micromet equipment. So basically, we use eddy covariance and surface renewal for the quantification of the sensible heat flux. Now, in terms of results, here is data on the seasonal ET, cumulative ET that we got in 2019 in 2016 and 17, and we saw pretty good separation between the different level of salinity in terms of seasonal ET, and the results also for 2018 and 19 were pretty consistent, and so we saw that separation in ET in a consistent way over the 4-year duration of the project. On a 4-year average basis, we determined that the non-saline mature orchard with about 72% of canopy coverage has a seasonal evapotranspiration of about 42 inches, and this is considered for the beginning of from the beginning of April to the end of October. And salt-affected orchard had a significantly lower actual ET than non-saline orchard, and the amount of ET reduction depended on the level of salinity and basically the tree vigor. Here is in this part we got a sense also of the reduction in ET based on the salinity level. Low saline had about 12% ET reduction, medium saline had about 25% ET reduction, and high saline, highly salt-affected tree had about 35% ET reduction. When it comes to crop coefficient, we know that in the valley, in order to schedule irrigation, growers normally use the crop coefficient values. They are reported in the pistachio production manual of 2005. And those values were obtained from a research study conducted during the late 90s on a sprinkler irrigated pistachio orchard. And we found out that for the non-saline orchard, the crop coefficient value for mid-season were about 20 to 30% lower than those that are reported in pistachio production manual for the sprinkler irrigated orchard. And here is a sense of in numeric value what we got. Here on the right, you see in blue numbers crop coefficient that we found higher at the beginning of the season, and then during the mid stage, those 20 to 30% lower KC value with respect to what is reported in the UCNR pistachio production manual. When we determined the crop coefficient values for salt-affected orchard, we saw that those orchards have progressively lower KC depending on the level of salinity. Here is a graph with the increasing level of salinity. Blue, green, yellow, and red are increasing level of salinity, and those are seasonal crop coefficient that we determine for a biweekly time step. Now, irrigating salt-affected orchard with the crop coefficients that are indicated in the pistachio production manual for non-saline orchard will probably lead to excess water and will lead to higher soil evaporation and probably an increase in the level of soil salinity because water evaporates and salt remain on the soil. And overall, we growers must be careful because they're gonna incur in higher energy costs for pumping. And so probably in the salt-affected orchard and the saline sodic soil, the water application can be reduced because the tree will not be able to take that water anyway because the soil's multipotential and reduce light interception. We also considered three parameters of the trees: the light interception as a proxy of the canopy coverage, ET, and not yield, in order to quantify some kind of reduction in the plant performance, the tree performance as related to salinity. Here, the FPAR, ETA, and yield for the different study orchard, and we were able to quantify by considering considering three parameters, performance parameter at the same time, that in medium saline soil, the performance reduction was about 18%. In moderate saline soil was about 30%, and in high saline soil, the tree performance was reduction was about 50%. The major long-term effect of soil water salinity is basically a reduced tree growth. And as you can see here on the graph on the right, we got the FPAR, let's say, canopy coverage curve over the course of the season, and you can see that NS is the non-saline and medium saline, and moderate saline and highly saline have a consistent pattern of canopy growth, but there's a degree of reduction based on the level of soil water salinity. In terms of water use and water productivities and water footprint, these are the parameter that we were able to determine with the data that we collected in the field. And we have here the actual water use, actual evapotranspiration, water footprint per percentage of canopy cover. I mean, amount of water used for unit of canopy coverage. This is the yield, and this is the water productivity. That means yield over ETA. And also we were able to determine the canopy productivities in terms of yield per percentage of canopy cover. These parameters are used now to understand how to somehow plant a pistachio orchard when you have a salinity problem. You probably might be able to increase the planting density in order to recover for some yield nut reduction and canopy coverage reduction as resulting from the salinity. The last thing that I want to point out is that we also compare the ground measure ET data with the remote sensing ET estimate using satellite, and we got interesting results. And this is to point out that pistachio is a different animal with respect to other tree crops. And we used a metric a model for ET estimate with quite sophisticated field calibration. And here you can see in this graph a one-to-one line with the measure ET value on the ground in ET estimated using remote sensing for overpass day, and also on the graph on the right, you got the same type of graph for the total number of days. So over satellite overpass and satellite non-satellite overpass day. And if there's no difference, or if the measurement and the estimate of ET are somehow in line, you will see that the points will spread around the one-to-one line. Conversely, we saw that there were quite a bit of difference in the ET estimated with remote sensing with respect to our ground measurement, and those differences were plus and minus. And as you can see here in this table, here is the relative mean difference between the ET estimate and the ground measurement on ET, and this relative difference varied depending on the level of salinity. But as you can see, on a non-saline orchard was in the order of 15% difference, and on medium saline orchard was in the order of 40 to 42%. And so this basically leads to the conclusion that remote sensing, very highly sophisticated model have somehow problem in capturing some of the parameter of the surface energy balance, and this will lead in overestimate and underestimate. As you can see here, there's an overestimation and underestimation with the remote sensing model metric. metric. At the end of this presentation, I'd like to acknowledge people who have contributed to this field research project. We got a bunch of UC researcher and a few collaborators, and also the farm manager, and also have to acknowledge the different funding agency that made all this possible. With that, I will stop here, and I'll be happy to entertain question if you have.
Great. Thank you so much, Daniele. You've done a great job staying on time. And we have one question for you in the chat, which is basically, when using vegetation indices to do salinity sample, should the field be sampled? Should the field be divided into bigger zones, or do random sampling?
Well, what we did is the vegetation indices that we consider were determined for the footprint, the area corresponding to the footprint area of the ET measurement station, so we could correlate the vegetation indexes with the ET and crop coefficient. But also, we used the vegetation indices throughout the orchard in order to understand the spatial variability of the processes. But our relationship were based on the footprint area of the ET measurement station, which is the area contributing to the ET measurement. I don't know if I answered the question, but
yeah. Thank you. So we have another question, which is basically about the EC measurements. The EC units that you used, was it EC for the soil extract or EC of irrigation water?
Actually, what we did is we scan the orchard with the electromagnetic induction, and this will generate a parameter, a reading of the apparent electrical conductivities. And based on the spatial variability of this measurement, then we did the soil cores, and we extracted this soil cores at different soil depth. And with the lab analysis, we were able to determine the ECE. So basically is the electrical conductivity of saturated soil paste. And we did this during the late part of the winter. And so basically in a wet conditions. And so this is a soil water salinity, actually the salinity of the soil water, but not of the irrigation water. So it's the results of many years of irrigating the areas with water. But also this is a kind of is not a water-induced salinity, is actually a native soil water salinity in those areas.
Okay, and we have another question, which is basically trying to get more details about ET computation. And I suggest that that they contact you directly. And I know we do a lot of educational activities in depth, so maybe that would be the topic of like an hour and a half or 2 hour seminar.
All right.
We have another question from about what salts were the main components of increased salinity in the field?
Okay.
Why you have higher salinity in the field? Is it accumulation of salts from irrigation water, or do you have another source?
No, basically these areas are former marine deposits, and so the main salts were sodium chloride, and there was some calcium and magnesium carbonate, but the majority is a sodium chloride because of the in the geological times. This was basically a marine area, and so it was then drained, and there was a lot of marine salt, so sodium chloride. And the sodium also made the high level of salinity, made the soil dispersed and deflocculated, and so there was also sodicity in the high level of salt-effective soil, together with salinity and sodicity, which made the soil difficult to manage because of lack of infiltration, water ponding, and so it's a typical situation of the Central Valley, in some area of the Central Valley and San Joaquin Valley of California.
Okay, and we have one more question about, cumulative effect of salinity on yield in the long term.
Okay, so this was the reduction was in the order of 15 to 35% on the 4-year basis, and you can see in my slide where I put the yield reduction is basically quite a bit yield impact of salinity. But this is the results of a few processes and a few physiological adjustments. But pistachio still can produce at the profitable level, even in high salt-affected soil.
Okay, great. We have 2 more questions, but we're running out of time. So I would suggest that you contact Daniele directly by email. And we're going to go to our next speaker, Kosana from Cooperative Extension Specialist from UC Davis. And she's going to talk about how we can use ET information for irrigation scheduling. Thank you. Kosana, you're next.
Hello, everyone. Thanks for inviting me. I would like to share my screen. And if somebody can confirm that that's visible.
You're good to go, Kosana.
Thank you. So I appreciate the invitation to present on practical uses of evapotranspiration data for irrigation scheduling. And we'll try to keep my time, but please remind me if I don't. To start with basics on evapotranspiration, I'm sorry if this is too basic for some of you, but it's always nice to repeat that evapotranspiration is the process that shows us how crops need to replace water that is lost to the atmosphere, and it needs to be replaced either with rainfall or irrigation. In California, of course, that's most of the time only irrigation. And crop water needs are explained through 2 biophysical processes, evaporation from the soil and transpiration from the plants. We have stomatal regulation of plants, often putting an obstacle to exchange between the water that is transpired and transported to the atmosphere. So these 2 processes are both important. And when we talk about decreasing the water use in agriculture, we often can work on decreasing evaporation and should not work too much on decreasing transpiration if we want to maintain the yields. With the climate change, there are 2 increasing concerns that the evapotranspiration amounts will increase. There will be bigger drivers from the atmosphere to take water. And there is a concern of decrease in water resources that will be available for crop irrigation. And crop water demand for irrigation is more straightforward in row crops than it is in orchards. And since orchards are such a big water users, we need to account for plant density. What is the canopy size, tree row orientation? What is the orchard floor management? What is potential cover that covers whole orchard or only ground? What are the soil types, if they're well drained or low infiltration soils? We need to account for soil water salinity and acidity. We need to talk about irrigation methods. What is the fruit load or nut load? What are the varieties we are having in orchard of interest? And what is the post-harvest irrigation management? And eddy covariance seen here on the left is one of the most direct methods, together with lysimeter. These are the most direct methods to measure evapotranspiration, but the eddy covariance systems are more mobile, and we can use them 1 year in one place, and next year or in a few months we can move it to another crop to measure evapotranspiration. I'm showing here full system that is, Forrest mentioned yesterday, around $50,000. We can decrease the price of this system if we replace the flux cluster with this, which is the most expensive part, with the very cheap, simple sensors to measure ET as a residual of energy balance showed here in this scheme. As Daniele said, this is what he used in pistachio very often, and this enables us to have higher repetition of our measurements, and there is not too much sacrifice of the quality and accuracy of the data. And most of the time for irrigation, we are interested in daily values or weekly. We are not interested in half hourly that scientifically are relevant for us to analyze in our lab. But if we are focusing on daily values for irrigation, we can ignore the soil sensors part, because on a daily basis, this levels out and we have near zero impact of the soil. So then we have an easy way to compute evapotranspiration from only net radiometer, a thermocouple, and a cup anemometer, very affordable equipment. And when we just use a thermocouple and a cup anemometer, we use surface renewal method instead of eddy covariance, and we call it surface renewal light station. In this cotton experiment, we had the full system, and I wanted to compare how eddy covariance, when it's directly measured evapotranspiration, compares to a residue of energy balance. So substantially decreasing the cost of the measurement, we can have nearly the same results of evapotranspiration measurements. And we use this opportunity in California crops I tried to present here the most different systems we have. One is a drip irrigated sweet cherry as a first left image. And it shows scaffolding above orchards that is deployed for evapotranspiration measurements. Then the middle image is surface renewal light station in celery crop. And this is a sprinkle irrigated at the beginning of the season, and later will be drip irrigation. And then we have eddy covariance in winter grow sugar beet with the surface irrigation at dairy farms. This is the newest project we started with Steve Kafka and Nick Clark to measure how these winter crops can use the water from winter precipitation and nutrients from previous crops, because sugar beet and safflower, the crops we are studying, are very deep rooted and can use a lot what is in the soil deep layers. So we see thermocouples and net radiometer at the light station, and then net radiometer, soil heat flux measurements, and sonic anemometer with thermocouples is deployed at these full eddy covariance stations. And thanks to this lower cost direct or semi-direct measurements of ET, we were able to install around 30 towers from LA to northern border of California, and we are planning to install another 6 to 10 towers this spring. So we are expanding our measurement network to inform remote sensing products, modeling efforts, and also crop coefficients for those that need to update for different agricultural practices, the crop coefficients they want to use for irrigation in the future. One example of this new development of crop coefficients is in sweet cherry near Stockton. And we found that 3 sites that we equipped because the grower we were talking to that is hosting our experiment offered us 3 orchards of different tree density, rootstocks, irrigation systems, and row orientation. So we wanted to see in this area of California where we have similar soil type and same sweet cherry variety, how crop coefficient can vary depending on these different factors that impact orchards. And we saw small differences between these three orchards. And the grower thinks that with the increase of the trees per acre, maybe he can get more crop per drop because the water use is similar. However, we are still working on our third season starting now. First two seasons, the rain affected the crop yield, and it was a late rain before harvest. A lot of harvest was lost, unfortunately. And in addition to atmospheric measurements, we are starting to install this new sensor you see on the left that is developed by Campbell Scientific that has 9 depths of TDR measurements up to 42 inches. And we try to install measurements under the dripper and between the 3 rows. However, it's new technology. We still don't have a good coverage of the measurements, but something that we will be doing in the future a lot. And we always try to measure stem water potential in perennial crops before and after irrigation to detect any potential stress in the crop. Because if we want to recommend crop coefficients based on our measurements, we want to know to recommend it for well-watered crop. Also, flow meters are used to monitor continuously water applications throughout the season. And we also try to compare our ground measurements with our colleagues' UAV flights and imaging that he tried to do on the day's Landsat 8 passages. So this is in collaboration with Under the Kosh, and he estimated evapotranspiration. So far we have only 1 day, and the agreement for that 1 day with this ETEC, which is eddy covariance, the reference value, and UAV ET was very similar. And this is within the uncertainty of the measurement that we can't get much better either. And we see that satellite Landsat 8 ET was close, but a little bit less agreement than UAV. And soon we are starting measurements in a project that was funded recently on water management strategies for super high density olive orchards in California. We want to update the evapotranspiration and crop coefficient values. It's sometimes use a constant crop coefficient when we have evergreen crops, but we want to show that this varies, and we'll be taking samples of the fruit as it's peat hardening season needs different irrigation, for example, to reduce the vegetative growth and improve the olive oil quality in the future. So we will be testing how different water applications can be done, either for improving the olive oil quality or developing the deficit irrigation protocols. And we would like to explore optimization of precise and efficient water management in olives based on the different atmospheric, soil, water management and measurements, and sampling the fruits throughout the season. Also soon, we will probably start measuring almond evapotranspiration with cover crops. We are negotiating right now a project to start and to see if this rule of adding 0.35 to crop coefficients when they have cover crop, as long as it won't increase the crop coefficient more than 1.15, if this rule holds, or maybe in canopy that almond develops, there is more decoupling between what's happening at the orchard floor and trees. And we want to see how these interactions impact the whole orchard evapotranspiration. And we will also be doing soil measurements and runoff measurements to see if there is a potential for these cover crops to improve the water infiltration during the winter time by reducing the runoff and storing more water in the soil to compensate for ET that might increase of the orchards during the later months. And potential future projects, we would like to measure young pistachio orchard ET. You can see on the left image how these trees are small and probably difficult to detect their ET from satellites or UAVs. So direct measurements would really be beneficial here, or maybe I'm biased because I'm a measurement person. And on the right is olive orchards with a lot of smoke that happened the last year. We would like to see how this smoke impacts the evapotranspiration and water use of the crops, and that would be a very attractive project. And we get a lot of questions related to water demands of crops with this lingering smoke effect. And there are many options for informed irrigation decisions based on evapotranspiration, since it's such a big component to take into account for irrigation management. There is a state CMIS network for reference ET to be downloaded and used with crop coefficient. If you want, please write me. I have a little document with instructions how to use and download evapotranspiration data from CMIS network. There is a spatial CMIS also freely available, crop managed, developed by UC Cooperative Extension. UAVs might be potentially good option too. I know many growers are having UAVs. There are other remote sensing tools, and we heard yesterday from Forrest about OpenAT, and there are different commercial options with on-farm sensing technologies that can be deployed to use the data from your own specific conditions. And then the CMIS and especially spatial CMIS, it's true that not whole California is covered in measurements and these stations. So there are maps developed for the grass reference ET on 2 kilometers spatial resolution. And the input parameters are from Penman-Mateed equation that are measured at these standard weather stations. And the crop manage is an excellent option because it is based on all and checks all these boxes I said earlier that are crop and site specific, and also uses past and future weather, ET, satellite imagery, soil physical and chemical properties, and also accounts for irrigation system efficiency and other related variables so that it can really give an accurate and timely irrigation and fertilization recommendation based on crop specific models. So it's an excellent tool to use for both irrigation and fertilization, and is free and research based. It also outputs irrigation time based on the application rate of the irrigation system, as well as recommendation for how frequently to irrigate. That's also very important, and it can be integrated in other software applications, very customizable, and the application can be integrated with in-field soil moisture and flow meter sensors. And the crop coefficients that we are developing, we are going to communicate to Michael Kahn and his team to expand the database for more orchard crops in the future. And with that, I thank you all, and happy to respond any questions or hear your experience with irrigation management that you would like to share maybe.
Okay, great. Thank you so much, Kosana. We're waiting for questions, but in the meantime, I have a quick question for you.
Yes.
What's cost of measuring ET or actual ET through a drone? How much does it cost? And how does it compare to like surface renewal method?
So surface renewal that we use can be decreased to around $10,000 to $12,000 per station, and it requires a pretty skilled data analysis. For drones, I think there are variable costs. Maybe you have experience with some drones that are used in that growers use, but I'm not sure how much skillful the user needs to be for processing images and how soon they can get the data.
Okay, all right, thank you. So looking at the question and answer chat, we're waiting for questions. We have a question for you. Have you done any work with atomometers? I have no idea.
Atmometers, it's a
atomometers, yeah.
Yeah, I have very little experience. I know they are very affordable tool or reference ET. My colleagues in Arkansas use it a lot because they don't have such a good statewide network. So it can be a good tool according to my colleagues, but I don't have much experience myself.
Okay, thanks. Okay, and we have another question for you. Have there been any smoke issues or concerns with the smoke in almonds? Any deductions in payments that you are aware of?
So taint issues. I'm not sure about that. It's beyond my expertise. I did have measurements in almond during the smoke, and they seem to decrease the evapotranspiration a little bit during the smoke, which is understandable given the decreased solar radiation. But
okay,
I'm not sure.
Good, good. I think you already answered the third question. The third question was about, the effect of fires on ET. Does it increase or decrease ET?
Yeah, I saw a decrease in ET in almonds and a decrease in ET in sweet cherry, except the sweet cherry harvest was in June and the smokes were in August and September. So I heard from pistachio growers that they had very good harvest, and they wonder if that's relatable to smoke, but we are not sure. I think some crops that have stomata on top of the leaf can be affected also with the physical barrier of smoke deposition, whereas almonds shouldn't be affected. But I did notice in my measurements some decrease in ET.
There's another question about crop row orientation and its impact on ET.
Yeah, the crop row orientation can mainly impact how much of the light is intercepted by the leaves and how much between the tree crops. So it can be a factor,
okay,
depending on the pruning and training of the orchard also.
All right, great. Thank you so much, Kosana. I know you have another commitment. So if we have any other questions for you, I suggest that they email you directly. And we will go to our third speaker, Raj Khosla from Kansas State University. And he's a professor and department chair, and he will be talking about precision water management in the Western Great Plains. Raj, the floor is yours. Thank you. You're muted. All right, that's great.
Good morning, Khalid, and thank you for extending the opportunity to share with you some of our work that we have done, my program and I have done related to precision water management. Well, it's not a surprise. We all know that agriculture is the largest consumer of fresh water, and this is true globally. This is on my left here on the slide is the pie chart that shows that agriculture consumes 70% of the global water use. Now, if you look at within the US, 40% of land is under irrigation, which is a very significant and among the largest on the planet. And here is a quick snapshot coming from USGA, a National Water Consensus data produced a year or two back. And the lighter blue colors indicate what are the primary irrigated states in the country. And so I want to draw your attention here that apart from Arkansas, Mississippi, and Florida, those are the three eastern or southern states. Majority of states in the western half of the US are the primary drivers of irrigated agriculture. All right, so let's take a little bit closer look at those 17 western states. Corn and forages continue to be the lead consumer of water, followed immediately by orchards and wheat of all types, vegetables, soybeans, cotton, barley, rice. This gives you an idea how we're consuming water in agriculture. That is coming from USDA agricultural statistics. If I were to quickly dive in, who are the key states in the US in terms of that are consuming water? California and Nebraska continue to lead the chart, a very significant consumption there of water. And I'm now located in Kansas. As of last month, we're the 6th largest consumer of water, followed immediately by Colorado, where I had spent the last 20-some years. So what would it take for us looking into the future in terms of water management in the Western Great Plains? Well, it will definitely require a multi-pronged strategy. Of course, we need new policy and regulations, implementation and practice of conservation, enhanced cropping systems, new genetics that are coming down the pipeline, dryland or rain-fed systems. And I think the core of all this would surround around, in my opinion, precision water management, what I'm going to talk for the rest of the time today. All right, so let's take a quick look at what are our current water management practices. Well, this is for center pivot irrigated system. When the time is right, farmer will flip the switch and would apply one depth of water throughout the pivot. Now, it's easier when you are looking at a landscape like this with so much topography and undulation. It's easier to realize that there is tremendous amount of spatial variability that would regulate water distribution, right? However, when you're looking like on a landscape like this, when the field is pretty much flat, it is hard to conceive the level of spatial and temporal variability that might be embedded in this kind of irrigated system. So for precision water management, when we got started about 10 or more years back, this is one of the furrow irrigated fields that my program has worked on for the last 15 years. And when we were thinking about installing a precision irrigation system on this field, we went out to get several bids for the system. And there was one consistent message that we got from all the vendors. And that message was, but this field is flat. I have looked at the Surgo data and it's all one soil type, one soil series. And in fact, it is one soil texture. Is this a good field for precision water management? Well, we took the approach like any soil scientist would and get down to start acquiring soil samples. So this is Louis and Raphael who went out and started taking lots of soil samples from the field. And lo and behold, of course, the texture of the entire field was one soil, silt loam. I want to draw your attention because I have given a lot of thought into this process over the years now. So this is sample A, sand 40%, silt 50-some%, and clay less than 10%, right? And on the bottom of my slide, I have a magnified particle size distribution. This would be clay, invisible even at this scale, silt, here's sand. And then, although we technically don't call soil anything larger than 2 millimeters, but we still have to deal a lot with gravel, right? So if I were to use this nomograph and use the sample A with the PSA, particle size that I shared with you, we're talking about that this particular soil sample would fall under silt loam, and rightly so. Now I will show you another soil sample acquired from the same field, okay? And here's the particle size analysis. Now what you have in front of you is 800% change in sand. You have 150% change in silt and more than 300% change in clay content. And yet, based on this soil textural nomograph, it still falls under silt loam. Well, this system dates back to more than 100 years, and it has served us really well. But it comes from a time when precision systems were not in place. Today, we have the capability to apply how much water we want, where we want, and when we want in the field. So I think it's important for us to remember that even a field that is not only flat, has one soil type, only one soil texture class, could have tremendous amount of variability, okay? It's hard to imagine that, but that's the reality. And so this is that field, the irrigated field that I'm showing you in the backdrop, that was then converted into a precision irrigation system, okay? And so this is the center pivot irrigation system. What you have in front of you is a pivot arm that has 30 drop nozzles, right? And we can control application of water at every nozzle level, okay? So I want to do a quick math with you here, all right? So water for this precision pivot can be varied at every nozzle level, and the change in the water application can occur for every 2 degrees of pivot movement, okay? For those who are in attendance, you may want to pull your paper and pencil out. So there's 360 degrees in a circle. We can change the rate of application for every 2 degrees, okay? That means 180 arcs. And then I have 30 nozzles, and this is a small pivot. This is not a very large pivot. And I got 30 nozzles. So when you do the quick math, mathematically speaking, this pivot has 5,400 water management pixels. It can potentially vary different rates of water as the pivot goes around the field more than 5,000 times. And this is really mind-boggling because we don't have the science to write a prescription map that would, one, quantify that scale of variability and write the prescription to be able to apply water in that 5 feet by 5 feet pixel that you see in front of you. And hence, I have mentioned this in my papers. I have mentioned this in many talks. The technology, I feel, in many ways is ahead of science. We have the technology to apply the right amount of water at the right time, at the right place, but do I have the science or a consensus to draw upon how much should I apply, where and when, and in which pixel? Okay, so lots of questions that requires attention. For example, does it even make sense to apply different rate of water in each zone? Does it? It's merit of investigating it further. And I'm sure you all have seen multiple different versions. In this case, the multiple pixels have been consolidated together to write this prescription map. When variability in the real world does not follow the patterns of pixels, you and I both understand that part. Okay, so what is the right approach? How much water should be applied, where and when? Okay, and how do we figure out how much water should be applied? Now that you have figured out a spatial pattern, okay, then how do we figure out the amount of water or the depth of water that needs to be applied in each zone or in each pixel, right? And how many zones are ideal for my field? Do these zones change over time? What is the temporal element of these zones? And if they change, which they do, by the way, how much do they change? All right, and how often do they change? So these were some of the questions that my program was grappling with when about 10 years back, we first installed our very first state-of-the-art precision pivot on that furrow irrigated field. And what about other parameters? Managing water is not that simple. We heard about so many interplaying components in the previous two talks. So I spent a lot of time with my growers who either have precision pivot or they're sitting on the fence. Should they convert it into a precision pivot? All right. And I said, where could I learn? The best place to learn is, boots from the ground, right? Boots on the ground. So when I've had these focus group meetings with my growers, trying to pick their brain, several questions came from the field. Number one, power and water application has a very strong relationship. So can this approach save me any power, right? It turns out the more you keep your pivot on, or keep your pivot running, of course, you're applying more water, but your power consumption billing goes down. And then another very significant question, can this approach save me more water? Can this approach, if I start working on increasing the efficiency and cutting back on water, both spatially and temporally, what is the impact on the production? These are the questions coming from the boots on the ground. Growers are not necessarily interested in basically maintaining their production. So the logical question, can this approach increase my production? And these number of questions are in no particular priority order. You could imagine the very first question that pops up, can I make more money? This is a resource intensive technology. There are so many questions that are still unanswered. And yet, if I were to engage as a farmer, if I were to engage in this technology, can this approach save me more money? Bottom line is, I walked away from so many focus group meetings that are organized around the state. I walked away with the sense that, look, there are more questions than we have answers. So came back to the lab, started doing brainstorming session. How do we figure out, okay, I can multiple labs around the country and commercial vendors can quantify spatial pattern, whether you're using remote sensing technology or boots on the ground, soil sampling, or a combination of those. But then how do we figure out how much water to be applied in each zone and each pixel? And so we started doing brainstorming sessions in my laboratory. And one thing came out loud and clear, that we need to know how much moisture is in soil everywhere in the field. That part came loud and clear. We definitely want to know that. And the practitioner kept on reminding us, look, don't forget the field is flat, has only one soil type, one soil series, and one soil textural class. Well, we went back to the drawing board. This is geostatistics 101. I'm sure many people in the crowd already knows about it. So on the x-axis, I have the distance in between the soil samples that I've acquired. And on the y-axis, I have semi-variance plotted, right? So what happens as the distance between the soil samples increases, your variability in the field increases. And it increases to a point where you have gone so far apart in the field that there's no longer any relationship. And that's what's referred to as reaching that plateau. And in spatial statistics, we always work on finding that spatial range. At what distance in the field, if I'm chasing a soil property of interest, does that distance, that relationship falls apart? Okay. And so keeping that in mind, anything that's outside of that distance would be totally spatially independent, meaning I may be spending a lot of money, but I really cannot create surface or cannot really predict what's happening in between my soil sample distances. And so when you know what the spatial dependence is, what the distance, that distance is, you have no choice if you want to do it correctly, that a field of this size, this is a quarter of a quarter section, so about 30 acres, will require about 100 soil moisture sensing nodes in order for us to do a predictive model at spatially dependent scale. Now, here's one sensor node. And you got a pole, you got 5 cables running down the sensor node. That's measuring soil moisture at 5 different depths. And then one cable goes to the top that's connected to the telemetry, and you got a solar panel. We did this work in 2012. Each of these sensor nodes were anywhere from $1,000 to $3,000 or even higher. Could you imagine putting 100 sensor nodes in a small field like 30 acres? And absolutely not. No farmer on the planet can afford something like this, no matter how much it is technically sound. And we couldn't do it either. Besides, there are so many logistical challenges. Even if you have a hefty grant to do this, there's a logistical challenge. How would you run your operations and tractors and so much machinery that goes within the growing season through the field? And so we actually did this work on one half of the field. Okay, so you notice on the right, I eliminated the top half of the field. And I had a visiting scholar from China, bless his heart. He was looking for a project, and we did the hard way because we couldn't afford the sensor nodes. So what Dong Wei did, he went out in the field and installed soil moisture access tube, and then used the nuclear probe to go out 12 to 15 times during the growing season and measure soil moisture at 5 different depths, 6, 18, 30, 40, and 54 inches depth, right? So what I'm going to share with you, this was a big learning experience for us. In an irrigated system with one soil texture class, with one soil series across the entire field, I'm going to share with you just a quick animation of the data that we captured, not at the 6-inch depth, which will be dancing all over the time. You and I both know that, but at 42 inches depth. Take a look. So this is our growing period, right? May through October. You visualize tremendous amount of spatial and temporal variability, even at that depth in an irrigated system. What we were thinking that at that depth, maybe we'll have a very uniform looking surface, spatial surface, so that I can then draw my polygons and call it that this field has 3 water management zones. But Mother Nature is not that simple. So let me give you a flavor of delineation of water management zones, the initial attempts that we did, and since then we continue to work on this topic. So this is one surface for 6-inch depth for the time that Dongwei went out and took measurements to 5 depths. And in this particular field, we did this work on 2 different fields. He went out and recorded data for 12 dates. So now you have 5 depths and 12 dates. And so you're dealing with 60 surfaces. How do you bring all of this data together? To share the complexity of this data, you have X and Y, right? You have Z, depth, and then you have time T. And parameters that we're chasing here, soil moisture, is dancing all over the place in all of those axes. In fact, we did this work. We published a paper in Soil and Water Management and Conservation, spatial and temporal variability of soil water content in level fields. Why I'm sharing this with you? It became loud and clear. We concluded that there is so much variability, even on precision level fields, that ideally, if we can measure soil moisture at spatially dependent scales, every time farmers gets ready to flip the switch to apply irrigation, there should be a different water management zone. So it's not frozen in time, what we refer to as dynamic water management zone for each time irrigation is scheduled. But again, the challenge is, how do we measure soil moisture? But that's one among the many drivers in this. So you got one field. To collect data at spatially dependent scale, you need, let's say, 80 to 100 sensor nodes. And this is how the sensor nodes that looked like in the past. They're expensive, time-consuming, and laborious. Now, going forward, we believe that this will change dramatically. And in fact, my group, along with the group from Berkeley and group from CU Boulder, we're working together on developing next generation of soil moisture sensors that are cheap, easy, and simple. Our targeted price is less than $1. Okay, but even if we get there, it would not be that easy. Our idea is that we distribute these sensors randomly in the field, take advantage of IoT. These sensors do not have battery, and you don't have to go back and collect these soil moisture sensors because we're using material that the soil moisture node itself will degrade after 200 days, after a crop cycle. So with that, I will stop right here and welcome any questions that you all may have. Thank you.
Great. Thank you so much, Raj. Very interesting presentation. We have the first question for you. It's very interesting point regarding the soil texture triangle. Do you think using % clay content rather than texture would be more appropriate? Just using % clay rather than soil texture.
I mean, that's a very interesting thought. But clay also comes in so many shapes and sizes. So I don't have a prescription right now to tell you that using clay is a better option. What I'm getting at is that nomograph has served us really well for the last 100 years, but precision ag wasn't even born at that time. We really need to take a look at that textural classification if we want to harness what technology is telling us it can deliver. We're not even close to that. That's what I'm telling you.
Okay, great. And you already answered the second question about the soil texture triangle. To what extent, can you tell us what material are used in biodegradable soil sensors? What materials do you use so you know it will dissolve after 200 days?
Right, we are using a whole suite of materials. I think we have nailed it down. We start from about a dozen or so. We perform accelerated degradation in the lab conditions before we went out into the field, i.e. in greenhouse conditions. And now we're down to 2 or 3 materials. One of our paper just got published in the Sensors journal. You can find more details about what materials we're using on that.
Okay, and there is a question about the spatial variability pattern change with time and depth, it seems like management zone would be appropriate to address spatial variability. Is that correct?
So Colin, you and I both know that it's not that simple. Would management zone get you to a finer level of water management? Absolutely, yes. But what our research is finding is that you need new management zone every time you're ready to flip a switch. The management zone that you used last time is no longer good a week later when you're ready to apply water. So, yeah.
Okay, great. And there's another question about can precision nozzles used on other irrigation systems, for example, drip systems?
Oh yeah, why not? Absolutely. I mean, it depends on how much money you want to spend on that, because you'll have to put so many additional valves in each line to be able to control the smaller sections of the drip system.
Okay, and does fertilization or herbicides change the reaction to absorption or soil structure?
I mean, this is a soil chemistry question.
Yeah, this is soil chemistry question. It's
we can discuss it in longer discussion. Yeah.
Yeah. So I would suggest that we have one more question, but we're running out of time. I would suggest that they contact you directly.
Okay.
We really appreciate your talk, and we look forward. Mike and I will look forward to working with you, and in the next few years. Thank you so much.
That's right. We have a common project. You're right.
Yeah.
Thank you.
So this concludes the session about irrigation optimization. We have a 15-minute break until 9:35, where we have the fourth session about the nutrient management. Thank you so much for attending. And if you have any questions for any of our speakers, please feel free to email them directly. Thank you, Raj. Thank you, everybody.
Thank you. Welcome back, everybody. Welcome to session number 4 of the 2021 virtual California chapter of the American Society of Agronomy's Plant and Soil Conference. This is the session on nutrient management. My name is Nicholas Clark. I'm the Agronomy and Nutrient Management Farm Advisor for UC Cooperative Extension in Fresno, Kings, and Tulare counties. My co-chair for today's session is Mark Cady. Mark, would you please introduce yourself?
Sure, I'm Mark Cady. I am a senior environmental scientist at the California Department of Food and Agriculture in the Fertilizer Research and Education Program.
Thanks, Mark. We'd like to take a moment to thank our sponsors for supporting this meeting, and also to all of you for attending. This session is a personal favorite of mine because nutrient management is one of the foundational aspects of crop production. And yet it still sits at the intersection of so many different disciplines, such as soil science, plant mineral nutrition, chemistry, hydrology, atmospheric sciences, animal science, and even engineering. And as such, Mark and I tried to build a session for today that showcases the breadth of all of the archetypal California agricultural management systems with the different and diverse approaches to nutrient management. So with that, I want to introduce our first speaker for today, John Cardosa. John Cardosa is a senior project manager at Sustainable Conservation. He works out of Sustainable Conservation's Modesto office and partners with Central Valley Dairies. John leads the organization's efforts around nutrient management and focuses on different practices and technologies which improve nutrient and water use efficiencies, water quality, and all while maintaining optimal crop yields. Today, John will be presenting a talk titled Crop Subsurface Drip Irrigation Systems Utilizing Dairy Manure Effluent with Dairy Forage Crops. John, please take it away.
Great, thank you, Nick. I appreciate the intro. So while I'm presenting today, I'm going to have my video off. I've been having some bandwidth issues, so I'll go ahead and just share my PowerPoint. and we'll get going. All right. Well, like you said, I'm John Cardoza. I come from a fourth-generation farming family here in San Joaquin County in California. I'm a certified crop advisor and a senior project manager for sustainable conservation and project lead for the Conservation Innovation Grant I could jump into. So as an organization, Sustainable Conservation, we partner with industry to find win-win solutions that address environmental issues and businesses' bottom lines. And we are California focused. So today I'm here to talk about a subsurface drip irrigation system that blends dairy lagoon water and fresh water to irrigate dairy forage crops while reducing water use and commercial fertilizer use and increase nutrient use efficiency. First off, I really want to thank the NRCS for the Conservation Innovation Grant, or the CIG, and all of our partners involved. All of our dairy partners, Western United Dairies, and University Cooperative Extension. As you can see, it takes a long list of partners to make this type of project and effort a success. I think it's really important to highlight and really talk about the importance of the California dairy industry to the nation. We're the #1 milk producing state, producing 18% of the nation's milk, producing over $6 billion in cash receipts in 2018, and over 50,000 jobs in 2014. As you can see in the map, the California dairies are really mostly concentrated within the San Joaquin Valley from Sacramento to Bakersfield. And in that region, that area, there's over 400,000 acres of silage corn and winter forage grown in the region. So there's a really big opportunity to scale and have impact. And before we jump into the system itself and the technology, I really want to walk through how manure effluent really moves through the dairy. I think it's important to understand that. So we're going to talk about starting from the right and moving to the left. You have your dairy barns with your flush lanes here in California, which is really just concrete where cows stand and do their business. From there, water flushes that effluent to your first lagoon. And from that first lagoon, at this particular facility, we have a solid separator, which is really a screen that just takes out the solids from your liquid. And then from there, the lagoon 2, which the liquids go to. And that's where we source for our filtration system for our system. And then from there, we subsurface drip irrigate out into our field to the left. And typically, normally dairies utilize, and a vast majority of them, use flood irrigation, and they use either fresh water strictly or a blend of both of manure water and fresh water to irrigate their crops. So the system should really look familiar. It's your typical sand media filtration type system, and we just added a few things to make this thing work. So I'm going to start by moving from our left to our right and kind of walking us through the system. So on your left, the smaller pump that's towards us is our effluent or lagoon water pump, and that's sourcing from a lagoon that you can't see. And then the larger pump in the back is a freshwater pump, and that's sourcing from either an irrigation district canal or a well. And then moving to the right, the two red things on both pipelines that you're seeing are flow meters. And then from there, the two pipes come together, we blend, and then it's filtered through the sand media tanks, and then out into a field that's behind the haystack that you can't see. A couple of things about the system you can't see, we do have two variable frequency drives that help throttle up and down the pumps. And then we do have an acid pump that does put in a small amount of parasitic acid that we're using to help keep our lines clean. So the filters are designed with double the capacity of an equivalent conventional SDI system. The backflush from the sand media filters really return to a lagoon, or in some cases to a tailwater return ditch. And within the filters, we have 16 millimeter grit sand. The tape itself that's in the ground is 13 millimeters thick. We place it approximately 12 inches below the surface of the soil, depending on the soil type. And then our spacing is on 40-inch spacing. And that's really to accommodate the silage corn, winter forage, and alfalfa crop rotations most dairies utilize here in California. That way, the tape doesn't need to be pulled up and replaced. You can really seamlessly rotate those crops through the years. So really right here, what we have highlighted is really where the magic happens on the system. As you can see, this is a butterfly valve. So the system uses a sensor to monitor and regulate the EC of the blend of manure, effluent, and fresh water so that it stays under a target EC. The system maintains the EC by automatically adjusting a butterfly valve that increases or reduces the amount of manure effluent in the blend. In order to adjust the system to meet a target blend ratio, the grower needs to determine what blend ratios will likely occur at different EC values. Since this will vary based on manure effluent characteristics, the grower first needs to run the system at different EC values and document a range of resulting blend ratios. With that knowledge, the grower can set the target EC as a way to control the blend ratio. These ranges can be further refined as the grower collects more data points from running the system over time. Correlating nitrogen applications with electroconductivity levels requires enhanced effluent water sampling events along with standard tissue and soil sampling. So why did we choose to go down the path of this system? Well, in 2014, here in California, we're experiencing severe drought, and a lot of farmers saw their water allocations from the irrigation districts go down to 0% in some areas. So it was a really big issue, and a lot of guys were in a big pinch. So dairies typically use flood irrigation and haven't had a way to use lagoon water with an efficient irrigation system. So during this time, I was already working with an outfit called the Irrigation Farms, and Nate Ray, who's in your upper left in the red, and he's a farm manager there, and we were working on another project already, and Nate really was concerned about his future water supply. And so Nate and Netafim, which is an irrigation manufacturer, had begun work on conventional drip irrigation and transferring their ranch to conventional STI. But conventional drip meant increased fertilizer costs and a missed opportunity of not using the readily available manure nutrients. Nate really had the idea to try and irrigate dairy lagoon water through drip tape, and he approached us and Netafim about it. So the opportunity to increase water use efficiency, reduce overall water use, and increase nutrient use efficiency, and potentially help the bottom line really align with what we were trying to do. So we all partnered together between the Irrigation Farms, us, and Netafim to really start the pilot in 2014. And this was an effort that was 2.5 years of really trial and error. And the system really was a Frankenstein type of system. So we were torching things off, putting components on. People were out there at all hours. Lots of hard work. We were working weekends, spending long hours at the site, really just trying to figure it out. And from that 2.5 years, that pilot, we saw a lot of positive results and a lot of potential for impact environmentally and economically. So because of this, we knew that a conservation innovation grant through the NRCS would be a really good avenue to expand the partnership and test the system and really demonstrate, that it does work. And I just really definitely wanted to point out again that the CIG model with the NRCS is really important aspect to the success of this technology. So from there, after we decided to apply for the grant, we pulled together a larger group, the Irrigation Farms, Netafim, 2 other dairies, University Cooperative Extension, Western United Dairies, and 2 contractors that includes Delaval Labs. And we applied for the grant to demonstrate it across 217 acres of 3 dairies. And each site had an adjacent comparable control flood field where we were sampling soils, freshwater, lagoon water, blended water, digestate, because one of the dairies did have a digester, leaf samples in season, and tissue samples at harvest. Really, a big difference between the pilot and the grant systems, where the pilot, we were really babysitting it, and really the project team altogether was really operating the system. During the grant, during these 3 other systems that we had in, the dairy producers and the farm managers themselves were really operating it. So in terms of incentives, we had some big wins coming out of the grant that we finished up. And because of that, we were able to successfully demonstrate that we were able to have adoption across the dairies successfully. So the NRCS included this as a practice standard, which is great. And we finished the grant out in June of 2020 with the goal to demonstrate the system can be successfully adopted by different dairies with different herd sizes, different management practices in different regions and different soil types. So the NRCS certified the system as a conservation practice. And so it is available now within California for cost share funding at $2,871 per acre. So dairy producers that is interested can go and apply for the system to have it installed. And this is under the Environmental Quality Incentive Program. The EQIP support has driven a lot of interest in the system, both in California and in other states. So our partner Netafim has been receiving a lot of inquiries from a lot of different places around the nation. The system is also qualified for the State Water Efficiency and Enhancement Program, which is SWEEP under California Department of Food and Ag. And during the pilot, I think it's important to note, UC Davis's Dr. Martin Berger and William Horwath conducted a study that showed 70 to 90% GHG emission reductions that were mostly nitrous oxide compared to our flood fields. So also, everything we do, we always look at economics and do an analysis there. So the change in net income, an analysis was done to compare system costs and evaluate the change in net income of transitioning from flood to manure STI and from flood to conventional STI. As costs will vary based on operations, the analysis is presented to provide information so that individual dairies can do their own investment analysis without EQIP cost share support. Both scenarios actually resulted in a negative change in net income as compared to existing flood irrigation systems. But with EQIP cost share support, switching to the manure STI resulted in a positive change in net income. The increasing scarcity and the cost of water also factors into the transition. Based on cost studies, the change in net income from switching to manure STI without EQIP support becomes positive once the water exceeds $211 per acre foot. So, once when we get into a severe drought, water costs increase. Just the water savings alone, if it gets over $200 per acre foot, this will pay for itself, and it just makes economic sense. So I'm going to talk about some of the results that we saw during the 3-year grant period. We're going to dive into yields, water applied, water use efficiency, and nutrient use efficiency. So the manure STI fields usually had similar yields to flood irrigated fields for both corn and wheat crops. Most of the manure STI fields produce those yields with less water, measured as yield per acre inch of water applied. There are many variables, though, that could have affected yields, so the specific impact of manure STI on yields remains unclear. A big source of variability was planting harvest dates, which were sometimes separated by weeks, leading to important differences in growing conditions. And working with dairy producers, yields are really, really important to them because they do need to feed their cows. And the way we measure was tons per acre, and generally held steady. Our yields generally held steady compared to flood. So the way we measured was median percent difference, and our median percent difference was 2.5% higher than our control flood field. And the highest that we did see in terms of yield increase over our adjacent control flood field was 17%. Water applied. So water use reduction is really a major draw of really any STI system. So what we measured was inches per acre, and we do have some missing data, as you can see on dairy 2 on corn of 19, and that was of the flood field because we had some inconsistency with our flow meter, and we didn't take that data into account. So we did have a decrease of water use compared to our flood field, and that was about 36%. Another example I wanted to talk about was at one of the dairies, the manure STI irrigated silage corn. We were able to grow 30 tons per acre on 27 inches versus the control field where we grew 25 tons per acre on 41 inches. So a big savings there. Water use efficiency. So really this is crop per drop measure. We measured yield per inch of water applied, and mostly due to differences in water applied values, it was higher. So the median percent difference that we saw here was 38%. So our water use efficiency was 38% higher than our control flow field. Nutrient use efficiency. We were drawn to the technology both to decrease water usage and to protect water quality. And in California, like other places, nitrate leaching is really a big groundwater problem. So we tracked nutrient use efficiency as a proxy for reduced leaching. We calculated pounds of yield per pound of nitrogen applied. So the median percent difference here was we had an increase of 47% higher in manure SDI field compared to our flood field. The manure SDI fields received less magnesium, which is an emerging environmental concern. These nitrogen magnesium reductions reflect how manure SDI allows growers to apply and time crop nutrients much more precisely compared to flood irrigation. Neither the manure SDI nor the flood irrigated field soils showed higher magnesium or electroconductivity, suggesting salt buildup was not occurring, which is a concern when using any drip irrigation system. And that's not to say it won't become a concern, but something that we didn't see and we monitored during our time. Definitely want to thank Del Valle Labs for really sample collection and lab analysis as well here. So lessons learned. Want to highlight some of the key ones that we came across and wanted to share with everyone. Whole farm nitrogen balance. As an analysis of nitrogen mass balance of the dairy is an important first step before deciding to switch from flood to manure SDI. The manure subsurface drip irrigation system more efficiently applies water and nutrients to crops than flood irrigation systems, meaning less water and manure effluent need to be applied to grow forage crops. Therefore, the use of the more efficient manure SDI system will not help dairies address a manure nitrogen surplus. Dairies with excess manure nitrogen should first determine how to get nitrogen balance with options such as a manure export plan. A comprehensive nutrient management plan will help evaluate that situation. Management and staff capacity is really important too. It's a new system, and our grower partner said there is a learning curve for both irrigators and management here. You know, conventional SDI experience was helpful for those that did have it, but still needed to learn how to manage manure within the system. The manure SDI system is designed with automation features intended to make the operation of the system more efficient. These automation features may require additional irrigator training. The irrigator should be able to read and understand the instructions and manage a computer module for irrigation scheduling. While many of the manual tasks associated with flood irrigation will no longer be needed, the irrigator will have to take on new roles, including adjusting manure effluent and irrigation blend to meet crop evapotranspiration, nutrient requirements, and system capacity. Maintain system operation within required performance specifications, such as adjusting the settings to account for changes in manure effluent concentration and backflush frequency. Operating the chemical injection system, manually flushing the drip tape periodically, and inspecting, repairing, or replacing drip tape and emitters as needed. So another biggie is having a secondary or tertiary lagoon. This is a qualification that we have in place for dairies that are looking to adopt the system. The secondary lagoon allows for more consistent solids coming into the system and more consistent operation of the system. And also a solid liquid separator is really important that we found as well. During the pilot, we actually were working with a dairy that had a single lagoon operation, and it still worked, the system, it required more attention. So to smooth the process in terms of operation of the system, it's important to have that secondary or tertiary lagoon in place. Another thing is really having a dedicated manure pipeline. One of the systems that we did have during the grant, we were feeding the system from quite a ways away, about a half a mile, through a concrete pipeline that was competing against other flood fields. We had cavitation issues, so it's really important to have a pressurized, dedicated pipeline to the system, at least during the time of irrigation, to be more successful. One last thing I did want to mention, I didn't have it on that slide, but I think it's important to talk about. For the system to be successful in terms of pre-irrigation or germination, you will need to use your flood system. It will keep that in place, or sprinklers. We tried to germinate with drip, and a couple times during the grant unsuccessfully. So it's really important to germinate or pre-irrigate with your flood or sprinkler systems. surprisingly, we did not have any issues with rodents, or a significant issue at least during the time. And I'm not sure if that was due to field selection, but that was one thing I thought was important to mention as well. So takeaways that we had during this conversation. So we have increases in yield, increases in water use efficiency, reduced overall water use, increases in nutrient use efficiency. We have 6 years of testing with proven results. The system is automated and can be automated as much as we want. We have up to 90% reduction of greenhouse gas emissions, and we do have that NRCS cost share funding available at $2,871 per acre. So I want to really thank our partners, and what we're doing next is really looking forward to supporting expansion, building interest and adoption, and developing resources to help conversion and operation. And really none of the manure SDI hardware components were custom made. So everything is really available, readily available, including the systems readily available now commercially. And they are all engineered together to handle manure effluent blended with fresh water as a nutrient source. Once again, just wanted to thank the NRCS and how important that CAG model is. We're currently experiencing demand from a lot of dairies and hog farms from multiple states. All 3 dairy partners that we partnered with during the grant have installed or are installing additional systems to irrigate additional acreage. That says something in itself. And we experienced, that significant demand in 2020 from a lot of dairies, which is great. And we received a lot, the last couple of years, received a lot of interest from supply chain involved with dairies. So Target, McDonald's, General Mills, and Nestle have all visited our project site at one point or another the last couple of years. My email's right there. If anyone has any questions that they think of afterwards, feel free to reach out. And we have additional detailed info in all of our reports on our website under technical resources. Thank you.
Thank you, John. That's a very impressive project. Kudos to Sustainable Conservation and to the project partners on this project for really sticking with it over the years to make this technology more viable or viable at all. And it really is a game changer. So we have a few questions from the audience, and I'll just forward them here. And first question is, does fertilization or herbicide change the soil reactions to absorption or soil structure? That might be a soil chemistry question.
Yeah, we really didn't track the effects of that. And most of our system sites only used a starter fertilizer during the course of the project. So a lot of fertilizer, commercial fertilizer, wasn't utilized.
Okay. Because you set up the irrigation system to match soil texture and use tissue tests, have you been able to increase from 1.4 to 1.65 nitrogen use efficiency applications to areas of more nitrogen need?
We did not track that either in terms of specific areas of the field, and trying to make it more uniform, I guess, in terms of application, besides just using the drip tape. A primary focus of the project was more about operations of the system and successfully really putting manure blend through the system successfully without any hiccups.
Let's see, we still have some time here. I'm going through, the question is, does applied water in the SDI account for both fresh water and manure water?
Yes, it does.
And when you did the nitrogen use efficiency measures, are we correct in assuming that you included the N applied with the effluent in the calculations?
Yes.
Did you look at water loss by deep percolation when comparing the flood and SDI?
That's a really good question. I wish we would have, but we didn't have the resources. But yeah, we did not track water loss. But that was something that, going back, if we had the resources, we would definitely would have liked to do.
And another, here's a question I have, I just wanted to throw in. You looked at nitrogen use efficiency in terms of the applied versus removed ratio, but did you look at what the total nitrogen loading would be, the difference between the nitrogen applied and the nitrogen removed from fields? Because I think that's going to be a real important question for regulatory concerns, especially in the valley with the CV salts and the dairy general orders.
Yeah, so the kind of the protocol we followed was really in line with the dairy general order that the dairies have to follow, and that's the 1.4 to 1.65, and the way they do that is tracking the inputs of N, and then really tissue sampling at the end of tracking what was taken off.
Okay. Yeah, and then what data are you using to support the 90% greenhouse gas emission reduction?
Yeah, that's a really good question. And that was Dr. Martin Berger and William Horwath from UC Davis that did that study. And that study is available on our website under technical resources with additional information there in terms of everything that was taken into account.
And just again, I guess somebody was asking, what are the crops that are grown under the system?
Yeah, so what we evaluated was your silage corn for dairy silage corn, winter forage, which consisted of wheat or triticale, and that was it. And our hope is that it'll be eventually rotated into alfalfa seamlessly without any issues.
Okay, well, that's all the time we have for questions. And thank you, John, for bearing with us and on our questions and the really excellent presentation of a really important project.
Dr. Brent Holtz is the Pomology Extension Advisor in San Joaquin County and also the County Director for Cooperative Extension Programs in that county. And Brent, I'm going to keep it that brief because I want you to have all the time you can have. So please take it away for us.
Thank you, Nick and Mark, for inviting me to speak today at the Plant and Soil Conference. I think I'm going to tie in nicely with Daniel's talk. I'm going to speak about early nitrogen fertilization and why it's important on first year almond trees following whole orchard recycling. Last year, I shared a little bit on the Iron Wolf, which was a 100,000 pound rock crusher that we used to incorporate our first orchard that we recycled. And it has these huge 5 or 6 inch titanium teeth on this drum that weighs 25 tons. And it can crush rocks and trees and anything in its path. And we used it at the Kearney Ag Center. It can go forward and push over a tree and grind it up, and it can go backwards, and this head can rotate down and it can incorporate the tree. But it has a very unique style that I wanted to point out of recycling that's different from most of the orchards that we're doing now. You can see here a whole row was recently ground up and incorporated. And most of the organic matter is right where the old tree trunk used to be. And then there's space that didn't get as much. And then there's the next tree. But also there's a 10-foot strip where all the incorporation of the woody material took place compared to this 10-foot strip here that didn't get any incorporation. So the Iron Wolf produces very large chunks of wood. And also it is very uneven in its distribution in the soil. In this particular trial, we compared grinding the trees here on the right with the trees in the background were burned and the ashes were spread. And this is basically what happens to trees in nature in California. Either they burn up and ashes go back to the ground or they decompose gradually and nutrients return to the forest soil. So this trial, we had 7 replications at the Kearney Ag Center. And this is the trees are growing. I planted the next generation orchard exactly in the same spot as the first generation. And I like to point out that the rototilling of the iron wolf stimulated nut sedge. So in the first year, you could easily see the grinding plots by looking for nut sedge. Here's the second year, trees were growing well, and we didn't see a stunting, which I'm going to talk about later after this whole orchard recycling. Here's the third leaf on the left, the fourth leaf on the right. We had a very good crop. And the main points that I'd like to point out for this talk is over time, we had a significant increase in soil organic matter and a significant increase in organic carbon over time. And when you looked at trunk circumference, we also had a significant increase. We had 3 varieties in the trial. The Butte variety, which was the largest, the grind was larger than the burn. In the nonpareil variety, the grind again was larger than the nonpareil trees growing in the burn. And the Carmel trees, the smaller variety, were also larger in the grind than the burn. So the grind affected tree growth, and we had larger tree circumference in the grind treatment than the burn. When we looked at yields, we also had we had a slight increase in yield in the grind treatment than the burn. Sometimes it wasn't significant, some years it was, but always the grind was slightly ahead. But when you looked at a 6-year cumulative yield increase, we had almost 2,000 pounds more per acre of kernels in the grind treatment than the burn. So just to summarize that early trial, whole orchard recycling, it increased soil organic matter, it increased soil organic carbon, soil nutrients, microbial diversity, which I didn't get a chance to talk about. And it also increased the water holding capacity of the soil, which I didn't talk about, and it increased orchard productivity. But when the cogeneration plant started closing in 2015, because utility companies wanted more solar and wind power, not power generated by burning wood chips, several frustrated growers with a lot of biomass on their orchard floors rented these large manure spreading trucks and started spreading wood chips on the ground in a different manner of whole orchard recycling that when I first talked about. And nowadays, the iron wolf is not used regularly. It's only been used in 2 orchards in California on almond that I know of in a trial. And most orchard recycling now is done with these also 1,000 horsepower machines, but they're stationary and they can grind up the trees a lot more faster. They can do 15 to 20 acres per day. And I don't think I mentioned the iron wolf could only do about 1 or 2 acres per day. But this system involves about 5 or even 6 machines. You have an excavator not shown that uproots the trees. You have a front end loader that has to take the trees to this horizontal grinder on the top right. And then after the wood chips, the trees are all ground into wood chips, you have another front end loader that has to put the wood chips in a modified manure spreader. And then in the bottom right here, you can see the wood chips being spread on the orchard floor. And they're spread much more uniformly than in the iron wolf, and all the soil receives an application of wood chips in this method. So 5 or 6 machines are much faster than the iron wolf and much more efficient. And this is what's really done when we whole orchard recycling now. After the wood chips are spread, then we typically rip the orchard floor before we replant. And then the wood chips in the bottom right here need to be stubble disked or rototillered into the ground before we proceed with replanting practices. I just wanted to point out though, the orchard that I'm going to talk about next received 64 tons of wood chips per acre, and there is some nutrients actually stored in these wood chips. This particular orchard averaged 0.3% nitrogen, And so spreading 64 tons of wood chips back on the ground is, as there's almost 400 pounds of nitrogen in those wood chips, about 250 pounds of potassium, almost 800 pounds of calcium, and the wood chips are 50% carbon. So if you're putting on 64 tons per acre, you're putting on 64,000 pounds of carbon per acre. And these nutrients won't be available right away. They'll have to be released gradually as the wood chips decompose. But this is a picture here of a 2016 whole orchard recycling trial in Manteca, and where the wood chips were spread at 64 tons per acre. And in April, we noticed the trees started growing right away, and then they stopped. And then they didn't look like they were growing at all. And then we dawned on us that, as you can see from this picture, that there's not a single weed growing in this orchard, and it was a wet spring, and grower hadn't put a herbicide on for 1.5 years. So not only were the trees what we believed to be nitrogen stunted, but the weeds weren't even growing in this ground. So we doubled and even tripled our nitrogen applications in here, but we had a problem. The grower was fertigating to apply the nitrogen. And you can see the double line drip system here. And it's not a very efficient system to apply nitrogen to young, small trees that don't have expanded roots. The water and nitrogen in here would have been wasted that first year and only got to the tree here. And if we look at a close-up, sometimes the drip emitters line up nicely with the tree where they get the young tree wet, like on the right here. Sometimes the emitters, they don't line up very nicely, or they're running over this slight berm here, and the water's running down the emitter away from the tree. So double line drip systems are not an efficient way to apply nitrogen or water that first year. And so here with this grower, we started applying nitrogen granularly around the tree to make sure that we got it to the tree. We increased our applications that year. We applied almost 100 pounds of nitrogen, and that's about 3 times as much as normal. We usually apply about 30 pounds of nitrogen per acre per year on first year almond trees. So in June here, we hadn't quite caught up and leaf nitrogen percentage was still significantly less in the wood chip trees than in the control. By July, we had caught up, but as I had mentioned, we put out 100 pounds of nitrogen per acre. So we knew that we were pretty sure we put out too much nitrogen, and we could be more efficient with our use. In this particular trial, the trees that had the wood chips actually had larger trunk diameters than the trees that didn't in blue. If the trees were fumigated, they grew better than with the wood chips or without. But I throw this slide in to also mention that we don't expect wood chips to replace pre-plant fumigation. We usually do that in combination. But from this, this is the end of that first year. I showed you a picture of the trees growing in April where they stunted. This is by the end of the year, August or so. And the trees recovered. We got the growth we wanted that first year, although we used 100 pounds of nitrogen per acre. I throw this slide in because a lot of growers are concerned about the wood debris still left on the ground a year later after incorporating 64 tons per acre. This grower brought in this Northwest tiller, which does a good job of tilling and smoothing off the orchard floor. And when the grower did that, he was pretty happy with the orchard floor. But that's not the subject of my talk. Nitrogen is. And that work led us to a 2017 trial in Parlier with May Cullenber. And here we did a Latin square application of nitrogen, and we figured we needed to start applying nitrogen earlier. So the tree on the right got 0.8 ounces of N in March, while the control tree on the left didn't. And we immediately saw a tremendous growth response with that early nitrogen. in this whole orchard recycling situation. So and you see here in this trial, we made our applications with granular fertilizer around the tree and didn't try to fertigate our treatments in. And when we should have started taking leaf analysis earlier, like in March and April, but we did start in May. And from the leaf analysis data, we did put on 0.4 ounces, 0.6, 0.8, and 1 ounces of actual N, P, and K at a time. And from this, we saw that our early applications were much more important than our applications later as getting into leaf tissue analysis. And we also determined from this trial that we didn't get a benefit of adding more than 68 pounds of nitrogen per acre when we started earlier. So this trial allowed us to refine a little bit. We went from 100 pounds of nitrogen per acre the first year after recycling to realizing that 68 pounds was the maximum that we needed. That led us to our 2019 trial. And in this trial, we actually started adding fertilizer as early as possible at planting time. And we didn't want to burn our trees, so we only added 1/4 ounce of actual nitrogen per tree at planting time and watered it in. And here's our control without wood chips. And here is our treatment with whole orchard recycling with 70 ton per acre rate of wood chips. And here at the end of the year are the trees in the control growing. And here's the tree in the 70 ton per acre growing. And it actually looked like the whole orchard recycling treatments I felt were bigger, but that was just my biased opinion. But when we actually did trunk circumferences, the whole orchard recycling trees were significantly greater compared to the controlled trees. And keeping it in mind, both treatments received 5 ounces of nitrogen per tree or 45 pounds per acre. So we felt we had narrowed down our recommendation of nitrogen on first year almond trees even more to 45 pounds per acre. And when we looked at leaf analysis, in the same treatment trees, 45 pounds of nitrogen per acre, both receiving the same amount of nitrogen, we had significantly greater leaf nitrogen in the whole orchard recycling trees compared to the control. So I wish Daniel had been helping us follow nitrogen mineralization, because I think it was probably important. I don't know if we were feeding the microbes that released more nitrogen, or if we were, or if it was deficient in nitrogen. But anyway, we had a significant increase in leaf trunk diameters and leaf tissue with whole orchard recycling when we started fertilizing earlier. So now we have a nitrogen recommendation for first leaf almond trees, whether we're following conventional planting or whole orchard recycling. In conventional planting, Patrick Brown and the Almond Board have come out with a recommendation of 3 ounces of nitrogen per tree per year. And if you're following whole orchard recycling, we would up that number to 5 ounces of nitrogen per tree per year after whole orchard recycling. I need to warn people, we don't put on more than 1 ounce of actual nitrogen per tree the first year at a time, or we could have a burning situation of the trees with nitrogen burn. So we need to spread that out. Amisha Porritt-Peterson is leading now a CDFA project where we're optimizing fertilization and irrigation recommendations in newly planted almond orchards. And this involves myself and May Cullenber and Sudwan Gao and Greg Brown and graduate students Cameron Zuber and David Robles. May Cullenber has got her own whole orchard recycling project where she's monitoring with Sudwan Gao carbon dioxide and nitrous oxide emissions following whole orchard recycling. And to close, whole orchard recycling, I don't know if I've mentioned it yet in this talk, but it costs growers about $1,000 an acre to implement. It's very expensive. And fortunately, growers are starting to receive incentives now for adding the carbon back into the ground or not burning. The San Joaquin Valley Air Pollution Control District started in 2018, giving growers $300 to $600 per acre, up to $60,000 per grower to implement whole orchard recycling. And I just got some figures back from them. Since November 2018, 539 growers have received over $18 million to recycle, and they have recycled 25,934 acres, diverting 727,980 tons of woody biomass from being burned. So that's good. And in 2020, CDFA also added whole orchard recycling to its Healthy Soils program. And 14 growers in last year received 680,000 to recycle. And Karen Lowell mentioned to me in an email earlier or last week that they might have incentives for growers to recycle in the future. So we're excited to see these incentives coming forward for growers to recycle. And I think since 2015, since the cogeneration plant started closing, I'm guessing that about 40,000 acres have now been recycled. So not sure how I'm doing on time, but I'm going to thank our sponsors, the Almond Board of California, the CDFA and USDA, and of course the University of California. So thank you very much. And I guess I can take some questions.
Well, thank you, Brent. That was very enlightening. You know, it's been a long and winding road with whole orchard recycling, but it's you know, just a testimony to your persistence on this project of refining the recommendations and really making it happen. I should mention that Brent was involved a long time ago as one of the very and his dad, the first orchard growers commercially to be chipping wood instead of burning it with the orchard prunings every year. So Brent has a long history of working with wood on the ground. So I'm welcome questions coming in from the audience. One question is would it be better to instead of incorporating the wood chips right away to windrow chips along the side and let them compost before incorporating, the spreading and incorporation?
Well, certainly in several orchard crops, you know, like in pistachios and prunes, they often bring their wood chips in as a mulch on the berm for weed control measures. But in almonds, for instance, though, you know, since we harvest off the ground, we usually are trying to incorporate those wood chips as quickly as possible so that they'll get stuck to the ground and not come up with the almonds when we harvest them the third leaf. And we do tend to get more debris we pick up that first year in orchards that we've recycled. So we're usually trying to incorporate it as quickly as possible so that they will decompose or become part of the soil as quickly as possible so we have less debris at harvest time.
Okay, thanks. The question about diseased wood, is there a concern about spreading, you know, just recycling previous diseases back into the orchard?
There is a concern, and we've had about 10 sites where we haven't seen it become a problem yet. And I believe that you know, when the wood is actually decomposing, there's some pretty strong enzymes and cellulases that are breaking it down, and the organisms that were alive in most of this wood while it was a tree, I don't think are going to have a very high survivability. But you know, there are certain diseases that we worry about. We've had a couple growers with oak root rot, for instance, recycle their orchards. And, the idea of grinding up trees that could have oak root rot and spreading it around the orchard is worrisome. I've had a few growers do that though and fumigate. We don't see a problem yet, but I'm not going to say it's not going to ever be a problem.
And then I think we have time for one last quick question. Do you manage the particle size on the ground of the wood chips, and how coarse are the recycled almond wood chips?
Oh, very, very good question. And I forgot to mention that, the first trial, the Iron Wolf had almost what I would call bowling ball pin sizes of wood that got incorporated that scares a lot of growers, whereas but it might have other implications. The carbon may last in those bowling ball pins a decade longer. But to answer the question, with the horizontal grinders that are typically used now, there are screen sizes. And I forgot to mention that when you're grinding your orchard to recycle, we recommend using the smaller screen size, which is a 2-inch screen versus a 4 or 6-inch screen, so that everything that that goes through that screen is 2 inches or less. And we found that to be more manageable. So when we do recycle an orchard, we recommend using a 2-inch size screen or less.
Okay, well, we are out of time for this session, and I want to thank all of our panelists for really interesting and useful presentations. And we are going to take a break now, and we have a 15-minute break, and then we'll come up on session number 5 at 11:10, and we'll be discussing cover cropping. And so I welcome everyone to take a little break, but be sure to come back for that next session. And I'll see you all then.
So thank you for joining our session on cover crops. My name is Karen Lowell, and I am an agronomist with the Natural Resources Conservation Service based in Salinas. Before I forget, by your presence here, we assume you have some interesting cover crops, and I am going to post, I'm sorry I forgot to do it before, but I will do it right after I get Rex going, a link to a survey that Hossein Zakari from Chico State and some of his colleagues have put together with regard to fava beans. There's a link to the survey. I'll put a link to the survey and a bit more information in the chat. So please have a look at that and Hossein with his work. So to our session, cover crops are a really powerful tool, and they have many potential benefits. They can protect the soil from water drop impact and reduce erosion, also crusting reduction. They add labile carbon to the soil to support soil biological activity. They can provide above ground benefits for beneficial insects, pollinators, and so on. They may be used to decrease leaching hazard associated with excess nitrogen left in the soil post-harvest at the start of the rainy season. And they also have really important benefits for physical properties in the soil. The polysaccharides that the living root provides in the soil environment help bind soil separates and form stable soil aggregates, building structure with a lot of accompanying benefits in infiltration and water dynamics in the soil. Lots and lots of benefits of cover crops. But management is complex, and understanding how to fit cover crops in California cropping systems really requires a clear-eyed consideration of how they work or don't work in specific cropping systems. I like to say that management's like a spider web. You pull one side and everything wiggles. So the speakers that we've asked to present today are going to look at cover crops and sort of in specific considerations, including things like, is a diverse mix better than a monoculture necessarily? What impacts might pest dynamics have? How do you deal with planting into a crop, a seed bed that might have residues still in it, lots of different things. So we've tried to take a practical approach to cover crops that might kind of help us crack the nut in including them more robustly in some of our California systems where they fit, finding places where they fit. So I'm just going to pass it over to Rex Dufour from NCAT, and he will get us rolling. Take it away, Rex. Thanks.
Okay, thank you. And I'm assuming everybody can see the first
I can
slide.
see it. You're good to go.
Okay, thank you. All right, thank you. My name is Rex Dufour. I work for the nonprofit National Center for Appropriate Technology, which is and also runs something called the ATRA project, which is a National Sustainable Ag Information Service. It's a great resource for farmers and folks that work with farmers. But today I'll be talking about what we found this past year in some cover crops planted in a pecan orchard and the impacts on aphid populations. And I'd like to thank Karen an NRCS regional agronomist for inviting me to talk about this. And I'd also see here. There we go. Okay, right. I just wanted to thank the California Wildlife Conservation Board for funding this, the Environmental Defense Fund, and specifically Dan Kaiser for being a good partner, and also Pacific Gold and the owner Ben King for hosting this work in the orchard. And so next slide, please. Yeah. The project goals: develop cover crop mix to attract beneficials, including monarch butterflies. We wanted to monitor and identify beneficials coming to the cover crop and those going into the pecan canopy, and then monitor aphid populations and ID their primary natural enemies. And lastly, just get a better understanding of the dynamics of the beneficials relative to cover crop management and also the aphid populations dynamics in pecans. Next slide, please. So this is a map of the orchard, and those little dots represent the sample locations. The cover crop was sampled every couple weeks. At the 10 locations noted, we used 8 sweeps, 8 like half circle 180-degree sweeps at each location. We used sticky traps to monitor insects in the pecan canopy. They were hung between 6 and 10 feet high. They were changed every 2 weeks, except for the very first one that we put up in early June. And then aphid counts were done weekly. 3 compound leaves were taken from each of 2 trees at each of the 10 locations. So that's 60 compound leaves. We counted all the aphids and any beneficials we encountered, which would include spiders, ladybird, beetles of all forms, including egg masses and larvae and pupa, green lacewing, larvae and pupa and adults, and eggs as well. So, and anything else we saw. Next slide, please. A little bit about just collecting and sampling. We use cord mason jars, and on the right, you can see that blue funnel. That is actually one of those pet cones of shame to keep your dogs from munching on their hindquarters. That worked quite well as to transfer the insects from the sweep net into the mason jar. The mason jars were then put into a cooler that had ice in it. It slowed down the predators from eating each other and made our counts more accurate. At the end of the day, we'd go and put those mason jars in the freezer, and then we'd count them later on that week. And you could see the pecan leaf samples up on top there. So, yeah, next slide, please. The cover crop mix. Please do another click. Yeah. So we drilled 4 species. The top 4 species we drilled, the bottom 8 species we broadcast. And I know no growers would ever do this, but we wanted to give the seeds the best chance of germination and not burying them too deep or too shallow. What happened in the event at Pack Gold, we didn't see a single milkweed. That was disappointing. At a second orchard, Bypass Farms, with a brand new orchard, we did find a few showy milkweeds showed up. So, and we planted the same mix. Other plants that we used, the Phacelia worked quite well, crimson clover, Persian clover, and to a lesser extent, we saw California poppy and the sweet alyssum. So they all worked reasonably well. The poppy and the sweet alyssum tended to kind of hang out at the edges between the sprayed tree alley that was sprayed with herbicides and the alley itself with the cover crop, because there's a little bit more less competition at those edges, I think. But we figure all the competition from the other cover crops probably impacted the germination and growth of the milkweed, as well as any that did germinate and grow eventually got mowed. So also there were large patches of white clover in the alleys, and we didn't plant white clover. We planted red clover, so I can only surmise that one, the red clover and white clover seeds got mixed up from our seed supplier, or the white clover, which is a perennial clover, was there already. Okay, here, next slide, please. So this is a cover crop, really vibrant and alive. It's late April. And in the front there, the blue flowers, you can see that's the Phacelia. There's a few pink flowers in the lower left. That's the Persian clover. You can see the crimson clover, the red, pretty crimson red clovers. You can see some California poppy, and kind of in the background on the right, you might be able to pick out a few sweet alyssums. And next, click again. And this is about a month later, and it's a different block. And some of these blocks, a couple of the northern blocks that had a lack of irrigation didn't have as dense and robust a cover crop, but this shows what happened. The Persian clover kind of took over from the crimson clover. This is all Persian clover. And I have to say, it was great going out to these fields. The Persian clover has a nice perfume to it, and it was a joy doing sweeps and aphid counts, actually. Next slide, please. So this shows another part of the orchard. We did alternate row mowing in order to try our best to conserve flower resources. On the left is that was mowed 2 weeks prior to June 3rd, kind of at mid-May. And it's mostly white clover, and you can see it's coming up. There's some grasses coming up as well. And the thing is, we had originally planned for a flail mow to be about 8 to 10 inches high. The machinery was not able to be set up to meet that requirement. So it mowed about 2 or 3 inches. So it really impacted the availability of the flower resources, the pollen and nectar. But you see, it did grow back. To the right is another picture of a just recently flail mowed, and you can see there's not much available for flowers in that. Go ahead. So looking at the aphid counts on the pecan leaves, so we did 3 monitorings, right? Aphid counts on pecan leaves, and beneficial counts on pecan leaves, sticky trap counts, and sweep counts in the cover crop. And I'm going to cover pecan leaf counts and sweep counts for the most part. We estimate that the cover crop saved the grower maybe one spray, although ultimately the grower didn't, due to low pecan prices, he didn't end up spraying anything. Go ahead, you can click again. And one of the sprays would have been a neonicotinoid, which is pretty hard on the beneficials. It's a systemic. But you can see the economic threshold till mid-August was up at 20 aphids per compound leaf. Those are the yellow aphids. And then it drops down to 10 aphids per pecan leaf on average And so we were able to watch the dynamics of the aphid population without any insecticide sprays, although they did end up doing an air blast spray kind of late August, early September. I suggested just do some water and maybe that'll get some of the honeydew, get rid of some of the honeydew. So moving on from the aphid counts, ladybird beetle populations in the cover crop. That picture on the right, that's just from one sample location. I felt bad after a while because we were killing all these insects, and I'll probably go to insect hell after this, but the alternate row mowing, I think, was helpful in conserving the populations for as long as we could. But you can see in that shaded area, the impact of the first mow. And then if you just put another shaded area to the right of that, it looks like a 28 May column with 11 adults and 4 larvae. There would be another 2 weeks. There's another mow that happens then, and then that really seemed to knock down the ladybird beetle populations. Although at the time, the ladybird beetle population, the adults were migrating up into the pecan canopy. So yeah, next slide. Kind of just got to move through these. Syrphid populations, I have to say I was a little bit disappointed. I thought syrphid populations would be higher earlier on, but they didn't really show up until later in the season. And the adults became quite prolific. When I was doing leaf samples, there would be 2 or 3 syrphid fly adults just buzzing around the leaf samples, you know, looking for a little nourishment from the honeydew, I think. But they were never abundant. The eggs or the pupae or the larvae were not ever abundant in the leaf samples, even though the adults were quite abundant. If I suspect if I had sampled up going through October, probably the larvae, the number of larvae I would have encountered would have increased pretty substantially. So just click again. I think there's another. That's typical of what, you know, when I was doing the leaf counts, there'd be these syrphid flies. The adults only eat nectar and pollen, and in this case, probably honeydew. The larvae are voracious aphid predators. Next slide, please. Minute pirate bugs. These, I've never seen so many minute pirate bugs. I don't encounter them too much otherwise in my work, but on the right is a picture of a crimson clover seed head. Why don't you click that again? Nope. Oh, shoot. All right. Please go back. I added a few bells and whistles to a few slides after I gave this version to you folks. So I would point out that there are 4 or 5 thrips in this picture. If you're an entomologist, you can probably pick them out. But there's also kind of in the middle of the picture to the left and to the right of that kind of white dot, those are minute pirate bug nymphs. And so we found that these nymphs and the adults were hanging out in the crimson clover leaf heads and munching on thrips. And that's why these populations really were through the roof in the cover crop sweeps. They did drop off after the crimson clovers started dropping off, and especially after all the mowings, and you could see a pretty dramatic decline in early June. But and the curious thing was, in spite of these large numbers of adults which can fly, we never found them very abundant in the canopy. To me, that was kind of a disappointment. Next slide, please. Okay, I'd note the slide on the graph on the left for the spiders, the top population is 80. on the Microhymenoptera, which we considered anything under 0.5 centimeter, so 5 millimeters or less, we considered a Microhymenoptera. We did not include native bees in that. These were just wasps. But their counts, that highest bar is 40. So these graphs are somewhat misleading. But what I wanted to point out was that these two populations of spiders and Microhymenops maintained more consistency throughout the season than almost any of these other populations. Okay, next slide. And so this is just a combined graph. You can see that orange peak at the beginning, that's the minute pirate bugs. The yellow peak at the far right, that's syrphid fly, all forms. And then you can see the ladybird beetle, kind of the dark blue kind of peaks a little bit early and then drops off. And then the spiders, had pretty significant populations and maintained pretty good populations throughout. But this is the cover crop, and spiders do move around through parachuting. But some of these other populations never showed up and some did. So next slide, please. I want to switch over to just the leaf counts. And these are the leaf counts of green lacewing eggs. And we counted the dark green, the light green, and the white eggs. So it's kind of an accumulation of even some artifact eggs, what I'd call eggs that had already hatched. But clearly the green lacewings were going up into the canopy, and their egg populations, kind of went up and down, but remained fairly consistent. Started kind of climbing later in the year. Why don't you click again? And I was impressed by, this is probably a second instar green lacewing larva attacking a winged aphid, black margined aphid, probably twice its size. And I saw that again and again. Spiders were going after these large aphids, and even ladybird beetle larvae. So that was pretty impressive. Go ahead. So these are ladybird beetle egg masses, larvae, and pupa counts. And you can see the ladybird beetle larvae kind of peaked early on and then went down. That's a result of the cover crops being mowed. That peak in later in the season in August, that's a result of that photograph on the lower right, because when these egg masses hatch out, I was counting egg masses, there's one egg mass, that's one egg mass, even though it has about 35 eggs in there. But once they hatch out, I counted them as individual larvae. So I found one egg mass that had recently hatched out. I would point out that there's another predator spider that probably munched on a few of these ladybird beetle larvae. But although I would note that the pupa also peaked around that same peak as the larva. And so that's the pupa are a later life stage. So that indicates to me that there's a vibrant adult population coming up. Okay, next slide. Okay, some conclusions and speculations. Cover crops provided significant habitat for a range of beneficial insects. Okay, some of the beneficials migrated into the canopy, notably the ladybird beetle adults, the green lacewing adults, syrphid fly adults were certainly up there. The Microhymenops went up into the canopy. We found lots of them in the sticky traps. I didn't find any mummified aphids, and my speculation on that is that there's a high predation rate from the ladybird beetle and green lacewing populations, and that did not allow, and they were eating probably parasitized aphids, but none of those parasitized aphids survived long enough for mummification to happen, or that's when the larvae of the insects impact the exoskeleton of the aphid. It turns kind of this beige, hard and gray, and then they carve a little exit hatch when they exit the pupa inside the aphid. Anyway, and notably the minute pirate bug did not show up either. Right, next slide, thank you. Ladybird beetles and lacewing larvae seem to be the predominant predators in this system, and the lacewing larvae are the only predaceous forms. Ladybird beetles, the adults and larvae, are predaceous on aphids. Secondary predators were the spiders, the syrphid fly larvae, and perhaps assassin bugs. We found also a lot of dragonflies. Dragonflies were flying around up above, above the canopy, preying on larger insects. Damselflies as well. We found in our sticky trap counts that we found wings of damselflies and dragonflies. Apparently our sticky traps were working as a buffet for birds. We found several feathers in there as well. Minute pirate bugs were no-shows, which was interesting. They just didn't migrate up into the canopy at all, in spite of high populations of adults in the cover crop. We'll conduct year 2 of cover crops and hope to reduce the number of mowings. We felt that that really impacted the beneficials. And then I would like to see more research on honeydew impacts on pecan production, because the growers, one of their main drivers, not necessarily aphid counts, but the honeydew that accrues on the leaves. And they say once the sooty mold starts growing on the leaves, it impacts the production of the photosynthesis levels of the leaves and subsequently the pecan crop. Next slide. Just about done here. Just a few pictures from my surveys. You can see the bottom pictures. There's the yellow pecan aphid, and then next to that is a black margined aphid. And on the far right, that's the black pecan aphid, which has a much lower threshold. It's an average of 1 per compound leaf, not 20 as the other ones, or 20 or 10. So different critter, different impacts. And the upper left shows a spider just that had netted an aphid. Next slide. And just a few resources. We actually, ATRA has a sustainable pecan publication that's geared more towards the Midwest and South, but it does have some good information in it. And these other folks have real good information on those URLs. And I think that's about it.
Thank you, Rex. I don't see questions in the Q&A yet, but if folks do have questions, please feel free to type them in. One of the things I took away from your talk, Rex, just now was, what you plant isn't necessarily what grows.
And that's for sure.
It's one of the complicating factors when we, some of those seed mixes are expensive. So thinking carefully about what you want to invest in for seed and how you're able to optimize germination and establishment of the stand you're looking for is part of the complexity of managing cover crops.
Yeah, and next year will be different, even if we use the same cover crop mix.
Yeah. It's one of the humbling things about making a living growing things. You never get to feel particularly like you're on top of your game.
One thing I wanted to mention, though, cover crops, as you mentioned in your preamble, have many benefits. And we just looked at the kind of biointensive pest management approaches. But Lauren Hale of USDA ARS was looking at soil dynamics. And hopefully that research will, or those results from this last year will come out sometime later this year. I'm looking forward to that because she was looking at, bacterial, fungal interactions, that kind of stuff, as well as nitrogen dynamics.
Yeah, for sure. And there's water dynamics to be considered too,
yes.
Not least in the era of Sigma. Eric Brennan's done a lot of work on looking at the biology in soils that are cover cropped as well. So there's a lot of good information about some of these things, but managing them in our systems is really a significant part of it too.
Yeah. I should also note that the PCA that worked for Ben had never worked in an orchard with cover crops before. And, you know, I warned him like, well, the dynamics are very, very different here. You know, it's a whole different system. So.
Okay, I see Sherry's prompting me that we're over time, but maybe my clock's wrong. But there is one question that Lauren has for you that I think I'll have to ask you to look at separately, Rex, because we need to queue up Angela Florence,
Sure.
our next speaker. So Angela, Sherry, and Rachel, can you get Angela up for us?
Thank you all.
Thanks, Rex.
Okay, hello there. So my name's Angela Florence, and I want to talk to you today about the growing body of research out there that compares cover crop mixtures to cover crop monocultures. And specifically, I want us to talk about whether diverse cover crop mixtures do better than cover crop monocultures. And I think this is an interesting question because if you look across institutions, platforms, publications, you find that it's been widely presumed that cover crop mixtures are better than cover crop monocultures. They're alleged to be more productive, more stable. They're alleged to suppress more weeds, retain more nitrogen, promote soil biology indicators more, conserve more soil water, and even promote subsequent crop yields, more so than monocultures. That said, if you actually look at the research, what you'll find is that it mostly shows that monocultures can capture the same level of these benefits as cover crop mixtures. So one of the things I want to talk about today is why is there such a disconnect between the research on cover crop mixtures and the narrative around cover crop mixtures? What's going on that so much is getting lost in translation? And that's what I want to spend about half of today's talk on. So one thing that's happening is publication bias, and that's not specific to cover crop mixture research, so I won't dwell on it, but that's just the bias where research that shows an effect of a treatment is more likely to be published than research which shows no effect of a treatment. And then another thing happening is confirmation bias or cherry picking, and that's the tendency of all of us, whether intentionally or not, to selectively see and share information which supports our pre-existing beliefs. So the result of these two biases is that we're only ever really talking about a fraction of the cover crop mixture research that exists, which in and of itself would be a problem. But on top of that, the research that we're talking about has problems with it in terms of how we want to interpret it. And three of the problems I want to talk about are missing monocultures, confounding variables, and mistaking average effects for absolute effects. So let's talk about each of those things in a little bit more depth. So first off, missing monocultures. What do I mean by missing monocultures? So let's say we're interested in seeing if a 9-species cover crop mix can produce more biomass than cover crop monocultures can. How would we design that study? So one approach would be simply to compare that mix to each of those species planted out as monocultures. So you might do something like this. And this is just a subset of data from my own dissertation that I want to use to illustrate a point. So on the right here, we have the biomass of a 9-species mix. And to the left, we have each of those species planted alone. As you can see, the mix does not produce more biomass than the most productive monoculture, which in this case is rapeseed, that purple bar. Now, that's one approach. Another approach is to compare the mixture to a fraction of its constituent species as monoculture. So for example, if we compared the mixture only to oats, and our study looked like this. So let's say this is our study. Yeah, for sure, the mixture here definitely produced more biomass than the monoculture, but it would be really inappropriate to interpret this as mixtures being able to produce more biomass than monocultures. And yet, this approach to the science and interpretation is really quite common. So that's one problem. The second problem is confounding variables. So when you're comparing cover crop mixtures to monocultures, it's always important to make sure that they were given the same environment and management. So certainly you would want to plant these treatments at the same site, on the same day, using the same seeding rate, using the same planting method, making the same field management decisions across the treatments, and you want to sample them on the same day using the same sampling protocol. Because if you don't do these things, you're going to risk confounding the effects in environment and management with the effects of the cover crop treatments. That is, when you're looking at your results, you're not going to know if the differences you're seeing are because of your imposed cover crop treatments or your unintentional environmental and management treatments. So that's all pretty straightforward science 101 kind of stuff, where cover crop mixture research kind of gets a little tricky is when it comes to seeding rate. So what does it mean for a mixture and a monoculture to have the same seeding rate? So I want to spend a little time talking about cover crop mixture seeding rates. So there's no strict rules for deciding the seeding rate of a cover crop mixture. You can do it absolutely however you want to do it. That said, there are some general approaches that I want to talk about, and I want to do so using an example. So let's say there are 3 species, and for the sake of simplicity, let's say they're each planted at 9 seeds per square foot in monoculture. So something like this. Let's say this is each of our 3 species. They're planted at 9 seeds per square foot. Okay, how would we mix these for a mixture? So one approach would be to multiply each of these rates by 1/3 and then add them together and get something like this. So we still have 9 seeds per square foot. You'd call this a substitutive seeding rate, right? Because we're just substituting each of those spots out for a different species. People would also describe this as being 100% of the monoculture rate, because 1/3 plus 1/3 plus 1/3 equals 1. So this is a very common approach with cover crop mixtures. Another approach is to go above the substitutive rate, which is anything above 9 seeds per square foot. So for example, you could just add all the monoculture rates together. You could add 9 plus 9 plus 9, get 27 seeds per square foot. So you would describe this as being 300% of the monoculture rate. Also, people would consider this an additive situation. And for the sake of comprehensiveness, you can also go the other way. You can go less than substitutive, anything less than 9 seeds per square foot. This is not so common. Okay, so is it fair to compare monocultures to mixtures which are seeded at greater than substitutive rates? So for example, if these are our monocultures and they're all seeded at 9 seeds per square foot, is it fair to compare it to the performance of this mixture, which is seeded at 27 seeds per square foot, or 300% of the monoculture rate? So for the sake of argument, let's say that this mixture actually does in fact produce more biomass or suppress more weeds. Is it fair to say from that data that mixtures are better than monocultures? I would say no, because what if the monocultures would have also produced more biomass or suppressed more weeds if you tripled the seeding rate? We don't know, because in this hypothetical scenario, that's not how we planted the monocultures out. So when you're looking at any cover crop research, it's important to keep in mind that seeding rates affect cover crop performance, and that this is true of monocultures as well as mixtures. As you increase seeding rate, you shouldn't be surprised to see changes in things like biomass productivity, weed suppression, nutrient retention, soil biology promotion, soil water use, so on and so forth. And the result of that is that when seeding rates are not substitutive, you've confounded your treatment effects with seeding rate effects. You can't tell if your results are due to your imposed treatment or to your unintentional seeding rate treatments. So the third issue that happens is mistaking average effects for absolute effects. So let's return back to that data I showed you earlier and just focus on total biomass here. So the mixture here produces about 3,100 kilograms per hectare. Okay, so I do this study, I want to compare mixture biomass to monoculture biomass. What do I compare it to? Well, a very common approach is to compare it to average monoculture biomass. So here's the average monoculture biomass, about 1,600 kilograms per hectare. So you look at this, you could say something like, mixtures are almost twice as productive as monocultures. So that's technically true, but also I think very misleading. A lot of people would read this as meaning that mixtures can outproduce monocultures by 2-fold, which is clearly not the case here. The mixture does not, in fact, produce any more than the monoculture, much less twice as much. So another question for you, which of these 2 comparisons is of more relevance to cover crop management? I would argue that is definitely the second comparison, because a farmer's not deciding between planting a mixture or dividing his field into 9 sections and planting out all the monocultures. He wants to know if planting a mixture is going to help him more than planting a really good monoculture. So anytime you're evaluating the assertion that mixtures are better than monocultures, I encourage you to check 3 things. The first thing is to check whether there are any missing monocultures, because this is very common in cover crop mixture research. And then check if there are any confounding variables. Now I focused mostly on seeding rate, but you can confound any kind of variable. For example, I've seen sampling protocol be confounded and planting method be confounded with your treatments. And then assuming that the monocultures are not missing and there's no confounding variables, are the people talking about average effects or absolute effects? Because more often than not, people are talking about average effects, and it's important to keep in mind that has limited relevance to cover crop management. So if we take these 3 things into account, what does the cover crop mixture research actually show? So that's what myself and Andrew McGuire over here on the right wanted to know when we did this systematic review. And we asked the question, do diverse cover crop mixtures perform better than monocultures? And from the very get-go, we said, we're only going to look at studies where all the monocultures have been planted out, and where at the very least the seeding rates have been published. You'd be surprised how often the seeding rates are not published. And then we're going to compare the best mixture to the best monoculture. We're not going to look at average performance. So let's look at the review process first, and then we'll look at the results. So why did we do a systematic review instead of, for example, a traditional literature review? Well, a systematic review is a lot less susceptible to bias than traditional reviews. It's protected from cherry picking because our search strategy is documented and replicable. You should be able to look at our paper and you yourself do everything that we did. So here's what we did. First, we identified any paper that could possibly help us answer our research question. So we searched 3 databases for the words cover crop or green manure, and then additionally any variation of the word mixture, polyculture, cocktail, or diversity. Okay, the result of that is we got a lot more papers than were relevant. We screened out anything that didn't have to do with plant mixtures, and then we moved on to our eligibility step. In order to be eligible for our systematic review, you had to look at a mixture with at least 3 species in it. You had to test out all those species individually. You had to list your planting rates, and you had to be looking at a living cover crop on site. After all that, we have a list of articles with which we can extract data and summarize and answer our questions. So what data did we extract? We extracted any data that could possibly fall into the 7 categories that I mentioned on that second slide. We looked at cover crop productivity data, weed suppression, nitrogen retention, soil water, soil biology, crop yield, and stability data. So all told, we found 36 papers which met our eligibility criteria. Those 36 papers came from 27 unique studies. You can see them numbered there from earliest to latest, 1 to 27. These 27 studies had 119 eligible site years. They span 10 countries, and within the US, 12 states were represented. So you can see the wide variety of locations right there. You can see when these studies were conducted. Note that most of these studies were conducted in the past 10 years, where interest in these highly diverse cover crop mixtures has really been at its peak. I also want to point out that if you look at data set 16 there, that's my own dissertation work at the University of Nebraska. Now, back in 2013, when I was doing this, I thought I was doing something really unique and different. But it actually turns out that a lot of people across the US and the world were doing something very similar. And that ends up being really delightful because unintentionally, without consulting each other, we ended up replicating each other's results with a great degree of robustness. And I want you to keep that in mind as we look at the results, that these results were consistent from Poland to Japan to Canada to Switzerland, to Nebraska to Louisiana, so on and so forth. So the cover crops that we looked at were planted anywhere from February to December. This gray bar represents when the cover crop was in the field. You can see a portion of those cover crops were overwintering cover crops there in the bottom panel, and were allowed to persist into the next year. Biomass was sampled anywhere from 32 to 270 days after planting. And these cover crops were found in a variety of cropping systems. A lot of them were coming after small grains harvest, but they were also in soybean, corn, vegetable, orchard, vineyard, alfalfa, and sod systems. So a lot of different agricultural systems were represented here. If we look at mixture rates, they ranged widely from the low end. Mixture seeding rates were at 54% of the rate used in monoculture to the high end, where they were at 347% of the rate used in monoculture. And looking at this, I want to highlight the importance of listing mixture seeding rate in your article, because you can't make any assumption about how somebody is going to do it. Now, 17 out of 27 studies did, though, use a substitutive design. And then the next most popular approach was to go greater than substitutive. And then a few studies did use less than substitutive mixtures. So now let's look at the results. Let me peek at the time here. Okay. So first off, biomass productivity. We extracted 95 published comparisons between the most productive monoculture and the most productive mixture in terms of dry above ground biomass. So if we think back on this bar chart, we would have extracted the most productive monoculture biomass, which in this case is 3,500 kilograms per hectare, and the most productive mixture biomass, which in this case is 3,100 kilograms per hectare. We can plot it like this on our figure. On the x-axis, we have monoculture dry biomass. On the y-axis, we have mixture dry biomass. And then this dashed line indicates a 1-to-1 correspondence where they're equal. So that dot is pretty close to the line, right? So that's one comparison from one site year from one study. What do the other 94 comparisons look like? Okay, so 68 of the 95 comparisons were not significantly different from each other, which is to say there was no significant difference between the mixture and the monoculture dry biomass. You can see this by the fact that they mostly fall along that dashed line. There were, then the plotting point indicates the seeding rate of the mixture. So most of those are circles indicating that mixture is a substitutively designed mixture. Some of those are plus signs indicating that we have a greater than substitutive mixture, and some of them are minus, indicating a less than substitutive mixture. So there were some cases where there was a significant difference between the mixture and monoculture dry biomass. Of those, 17 of them were cases where the monoculture produced more biomass, and 2 of them were cases where the mixture produced more biomass. You can see those 2 red plus signs above the dashed lines. Note that these are plus signs indicating that these 2 cases were where the mixture was seeded at elevated rates compared to the monoculture. So in addition to that, we have a third category of data where treatment means were published. So we can plot the mixture and monoculture biomass here, but the statistical data was not published. And so we don't know for sure whether or not there was a significant difference between the mixture and monoculture, though we can tell that most of these points do fall on that line. So overall, the picture painted is that cover crops have immense capacity to produce biomass in the off season, but that monocultures can do this just as well as mixtures. So let's talk a little bit about weed suppression. A very similar story here. We had 56 comparisons of weed suppression. Of those 55, there was no difference between the mixture and the monoculture. There was one case where the mixture did do better than the monoculture significantly, but that mixture was seeded at elevated rates. So yes, cover crops have immense capacity to suppress weeds. You see how many of those points are above 80% weed suppression. But no, there's not really a big difference in how mixtures and monocultures are able to do this. So with regard to nitrogen retention, we looked at it in 2 ways. We looked above ground and below ground. So looking above ground, we looked at above ground biomass nitrogen, because the more biomass nitrogen you measure in your cover crop, the more nitrogen is being retained by that system that's being protected from, for example, leaching losses. So that's that data. Okay, but you can also look below ground, because as you have that growing cover crop that's taking up that nitrogen into the biomass, you're going to see reductions in the below ground mobile nitrogen pools. And that reduction can also serve as a proxy for nitrogen retention. So if we take these 2 figures into account, the top is biomass nitrogen, the bottom is soil nitrogen reduction. Here's what we see. Out of 35 comparisons, 32 showed no difference in nitrogen retention between the mixture and the monoculture. We have 2 cases where the monoculture did better, 1 case where the mixture did better. And again, this mixture is seeded at elevated rates. So yes, cover crops can retain nitrogen. No, mixtures don't necessarily do that better than monocultures. So with regard to soil water has a more complex relationship with cover crops than perhaps some of the other metrics. And that's because cover crops can cause the soil to decrease in water or increase, depending on how different processes balance out. So when you cover crop, you're going to lose water with increased transpiration, but you're also going to gain water with decreased evaporative losses and potentially increased infiltration, and in the long term, potentially increased soil water holding capacity. And depending on how these pathways balance out, you may have a wetter soil with cover cropping or a drier soil. And that was very much what we saw with the data. So on the axes here, we have soil water increase of the mixture in the monoculture compared to a no cover crop control. So when these points are positive, that is in the upper right quadrant, that's when the cover crop left the soil more wet than a no cover control. When these values are negative in the lower left quadrant, that's when the cover crop dried out the soil. You can see most of these points fall along the line. So just regardless of whether cover crops are net users or conservers of soil water, there was no systematic difference observed between mixtures and monocultures in terms of soil water use. You can see most of those points fall on the line. We do have 2 cases where there was a significant difference, but that's a case, those cases are both where the monoculture was favored rather than the mixture. So onto soil biology indicators. So cover crops can affect soil biology through a lot of different ways. For one, they add organic matter to the soil, but they also change the environmental conditions. For example, the temperature, the moisture, the soil chemistry, the soil physical properties, the soil fertility, et cetera. And so cover crops have a lot of potential to promote a lot of different soil biology indicators, and we saw that here. What we did not see was a big difference between mixtures and monocultures in terms of their ability to do that. Out of 35 comparisons, 33 showed no significant difference between monocultures and mixtures. There were 2 significant cases of a difference, and those favored the monoculture. So overall, no evidence that mixtures are better than monocultures at soil biology promotion. In terms of crop yield promotion, cover crops can affect the subsequent crop yield through everything we just talked about, through their effect on weeds, through their effect on soil fertility, soil water, and soil biology. And depending on how all those factors balance out, you may see the subsequent crop yield promoted or even depressed. Either way, we mostly saw that there wasn't a big difference between mixtures and monocultures in terms of crop yield promotion. In 11 of 14 cases, no significant difference. In 2 cases, the monoculture did better. In 1 case, the mixture did better, but again, the mixture was seeded at elevated rates. So let's move on to biomass stability. So the way to think about this is high variability means low stability. Low variability means high stability. And now I'm going to show you a graph where we've measured the variation of the cover crop mixtures. So here on the X, we have mixture coefficient of variation. Think of that as a metric of variability. And on the on the X, we have monoculture coefficient of variation. Again, think of that as a measure of variability. So 20 of the 30 comparisons, the monoculture had the lowest variation, as indicated by all those points above the dashed line. In 10 of the 30 comparisons, the mixture had the lowest variation, as indicated by all the points below the dashed line. So overall, mixtures have not been documented to be less variable than monocultures across sites and years. So back to our original question, do diverse cover crop mixtures perform better than monocultures? So if we just look at the comparisons where we had treatment values, control values, and statistical data published, this is what we saw. In 88% of those comparisons, the mixture and the monoculture performed comparably. That is kind of on that dotted line, no significant difference between the two. In 10% of comparisons, the monoculture actually did better. And in 2% of the comparisons, the mixture did better. And in these cases, it was always a case of the mixture being seeded at elevated rates. So overall, I would say that on the metrics that we evaluated, diverse cover crop mixtures have not been demonstrated to perform better than cover crop monocultures. What's encouraging about this, though, is that if you're looking to obtain the benefits of cover cropping, it appears that you can capture most of those benefits by simply planting a monoculture. With that, I want to thank you a lot for your time. And if there's any questions, I would love to hear them. Thanks.
Super. Thank you very much, Angela. That's a lot of information fast. So you do have some questions, and I will just go through them, and you can, I have a feeling some of them may be hard for you to answer because of the nature of the work you're presenting, but let's just work through them, see which ones we can get. How many pounds of nitrogen per % of organic matter? That's probably not a best one for you. Let me, apologies, I didn't read closely. Which mixtures do differences in species germination and growth affect biomass production? Do the species within the mixture compete with each other?
Yeah, definitely. So what a lot of people have found is that when you're doing a mixture, the more aggressive species will outcompete the less aggressive species. And usually the way that works out is the more aggressive grasses and brassicas will outcompete the legumes.
Okay. What were the biological indicators tested in the work you reviewed?
Ooh, let's go back to them because it's a wide range because there's a lot of different tests you can do there. So am I still sharing my screen?
Yeah.
Okay. There we go. So you can see we have some of the more direct counts like spore counts, and then some of the more indirect measures like what's the soil organic carbon looking like.
So this talk will eventually be online. So for the person who asked that question, you might want to go and pull that. Did you do anything to measure disease pressure on mixture versus monoculture?
Okay, so we actually didn't do any of our own original research for this. This was just a review of the existing literature, and that doesn't exist as far as we were able to find when we did our search.
Okay. Do legume grass mixtures retain more nitrogen in the profile than legumes alone? Did you have any way to review that in the data you were reviewing?
We don't have data that shows that specifically, but I would assume that when you add a grass to a legume, you're going to see more nitrogen retention than the legume alone.
Okay. Okay, well, I think we should thank you so we can get Gina queued up here. There were a couple more, and if you're able to see them in the Q&A, Angela, feel free to chime in and type an answer into folks. There's one that I wasn't quite clear I understood, but hopefully you'll have a chance to look at those.
Great. All right. Thanks for having me.
Positive feedback for you here in the Q&A as well. So Gina, let's move to get you set up. Very good.
Okay, great.
Thank you, Angela.
So thank you for having me here today, and I'm wrapping up the talks, I guess, here today. So thanks for sticking around. My name's Gina Kulfer. I work with Wilbur Ellis out of the Salinas branch in the Central Coast of California. So I just want to go over some work that we've done on a research plot down in the Soledad region of the Salinas Valley. So I want to start off by saying, so cover cropping has become way more mainstream, and especially in the upper Midwest and Midwest, where no-till conservation tillage and regenerative ag has really taken off and is now being proven as the way of the future for the wheat, corn, and soybean farmers. So this technique of regenerative ag incorporates animal husbandry into the equation, where a cover crop is grown, and then at time of termination, cattle, sheep, or goats are rotated in to graze it down. It's then planted with the no-till drill, and the crop can emerge through the cover crop mulch. This method is starting to be more widely adopted as demonstrations show the improvement on soil health and return on investment. And the Rodale Institute has put out a white paper describing the techniques and these successes. But in an intensive vegetable operation, the regenerative technique is not as feasible from a food safety aspect. There's a 1-year plant back date for any animals being on ground destined for leafy vegetables, and also stubble axes for an object risk on machine harvested commodities. Cover cropping and conservation tillage in a vegetable operation takes thought and insight on what is to be accomplished, and it needs to be handled on a field by field basis. When I think of all the benefits of cover cropping, the pro column is a lot longer than the con, but there are different reasons for each grower why the con column would be longer. Seed cost, land costs, do they lease or own that land? How soon does the shipper want the grower to plant? What is the food safety requirement? Or maybe it's just more trouble than it's worth. The incentives aren't there right now, but is that going to change now with President Biden's new executive order on climate recovery and storing carbon and paying growers for carbon sequestration? And also the Ag Order 4.0 is coming out saying that grass cover crops could be incentivized now for growers wanting to plant cover crops during the winter months at a 4-month time in the ground. So it is increasing in the Midwest, but will it translate over to higher value vegetable producers? Can these incentives be realized and profitable for the vegetable grower? So I think we're heading in that direction. So we need to give these tools to the grower now so they can start doing the research to measure short-term benefits, like in this picture, not losing topsoil to a rain event and increasing the health of their soil by increasing microbial biomass. So I want to start by considering what makes up a healthy soil. So there are 3 major components: the physical, which makes up the structural component, which ideally is 45% sand, silt, and clay, which is your soil, and then 25% air, so the microbial life in your soil can actually breathe, and 25% water, so they can have available moisture, and then 5% organic matter, so they have a readily available food source. And I know some are thinking that 5% is really unattainable, but can we focus on what is attainable? Maybe just maintaining what you have and not burning that organic matter off. So it is a food source for your biological component of your soil. And then the chemical, which makes up the nutrient content of your soil. So in looking at your CEC, a sandy soil has fewer exchange sites for your cations like potassium, magnesium, calcium, and sodium. So say you have a CEC of 10, you only have 10 spaces on that soil colloid for your cations to adhere. So it's better if we can increase those exchange sites to get more capacity to hold on to more cations, thus a more fertile soil. And calcium is important to help loosen the soil and important in cell wall structure. Magnesium regulates dispersion, flocculation, and essential for chlorophyll production and can influence pH. And potassium can leach in low CE soils, is a prime requirement in chlorophyll production, is needed so plants can make starch, sugar, proteins, vitamins, enzymes, and cellulose, and it regulates osmotic pressures in fluid cells. And sodium is okay in small amounts, but if higher than your potassium levels, can influence water uptake and may look like your crop is thirsty when it actually has plenty of water. And so balance is the key. The ideal pH is 6.5 to 7.5, and if on either side of those levels, nutrients could be tied up by those cations in the soil. And then lastly, the biological. So there's bacteria, archaea, actinomycetes, fungi, algae, protozoans, and nematodes, and they all play a role. If you can build the good bugs, can you outcompete the bad ones? Their roles include mineralizers, decomposers, pathogen suppressors, plant stimulants, and so much more that we're just really scratching the surface of that understanding of what they can do for us. And if we could build more biodiversity and biomass of microorganisms in the soil, then could the soil be more resilient to adverse conditions such as flood events and pathogen loads? And so a lot of organizations are starting to talk about carbon storage and offsetting. So it's important to know how much carbon you actually have in your soil to start with and how to store it for future generations. And also, really important, how to measure it. So I'm not going to run through all these bullet points for the matter of time, but just know that approximately 58% of the organic matter in your soil is carbon. So the more organic matter you can hold onto or even build, the more carbon is stored. And this is also the food source for your microbial populations in the soil. So the Soil Health Institute, California Department of Food and Ag, Natural Resource Conservation Services, United States Department of Ag are all promoting these metrics. But how to incentivize this in intensive farming without disrupting the planting schedules and food safety requirements that the shippers enforce? That's what it all comes down to. So in these next slides, I will be showing you my attempt at the feasibility of cover cropping and conservation tillage in a vegetable leafy green farming operation. So this research plot that Wilbur Ellis has in Soledad, California. So we farmed broccoli on the west 2 acres of this block, which is on the left side of this slide, and spinach on the east side 2 acres, so on the right side. After harvest of the broccoli and the spinach, so instead of incorporating the residue in disking and making the ground flat and then planting a cover crop, we decided to flail chop the broccoli with 2 passes, and then the spinach was already mowed from harvest. So we let it sit for 2 weeks to decompose a bit, then had the grower pre-irrigate for 6 hours to get good soil moisture. The irrigation water is contributing 1.6 pounds of nitrogen per acre inch. So we did get a little bit of nitrogen up front from this, from the irrigation. But the soil is very sandy with a CEC of 9 and an organic matter content of just 1%. So on October 1st, 2019, we direct seeded with the Great Plains seeder into the previously established 80-inch beds with the decomposing chopped material, but still the crop's roots were still alive in the ground residue. The cover crop that we planted was a grass legume blend of 30% cayuse oats, 30% common barley, 20% Dundale peas, and 20% fava beans planted at 100 pounds per acre. And no additional fertilizer was applied. We were depending on the residual nitrogen that was left at the time, where the broccoli had 26 parts per million of nitrate nitrogen, which equates out to 52 pounds of nitrogen per acre. And the spinach had 3 parts per million nitrate nitrogen, which is 6 pounds of nitrogen per acre, highlighting how broccoli can leave residual nitrogen in the soil, and then spinach can really leave it almost depleted. So this is October 16th, so just a little over 2 weeks after planting. So on the left is the broccoli stover, and on the right is the spinach. And you can see the grass got off to a pretty good start on both sides. So this is the same view on December 12th, 72 days after planting. And you can see how the broccoli residue on the left, the grass has significantly outcompeted the legumes in the blend. And now it really is a grass dominant cover crop. And then on the right, or the east side of the field, the spinach residue has become a legume dominated cover crop with some grass present, but not as vigorous as the grass in the broccoli residue side of the field on the west side. So I really believe this is because of the difference in residual nitrogen of planting between the two crops. And then this is the day that we chose for termination of the crop. The barley was starting to head out, and I didn't want it to get too fibrous, so breakdown would be slower. This soil, like I said, is very sandy and has very low microbial counts, so the breakdown would be slow. And we didn't realize it was going to be the driest February on record in the Salinas Valley, so there really wasn't a lot of moisture to help those microbes break down the biomass. So I knew it wasn't going to be there for a couple months. So I just chopped it and left the residue to dry down, and we kept the roots in the ground. So at time of chopping, we harvested 4 different areas within each side of the cover crops and measured the wet biomass. As you can see on the left, the grass is dominant in its population. And on the right, the peas and the fava were the dominant, but there definitely was some grass still present. Whereas this is broccoli residue still left over, and then there was just a couple little fava beans, and really the barley was dominant even over the oats. So we monitored the nitrates throughout the winter, starting when the cover crop was planted. And this confirmed that the broccoli had the residual nitrogen at 26 parts per million, and the spinach was at 3 at the time of planting. So that's why the broccoli, the grass, which requires nitrogen to get going, outcompeted the legumes. And in the spinach, the legumes outcompeted the grass because they don't necessarily need the excess nitrogen to get established. So this really tells me to know your residual nitrogen at planting and really what your blends, what you want to accomplish with those blends. And you can see that over here, when we terminated, the nitrogen did bump up a little bit on the legume dominant cover crop. So maybe a blend with legumes isn't the, let's see, I jumped ahead a little bit, isn't the best when you have a lot of N left over, and maybe grass isn't the best if you have no residual nitrogen left over. And so at the time of harvest, the spinach legume blend contributed some of the nitrate nitrogen to the soil at just below 10 parts per million. And then the broccoli grass blend really had 0 parts per million. So because I left the residue on the field for so long, it did dry down and didn't break down the way that we were really hoping. We utilized the technology of the reverse mulcher to incorporate the residue, hoping for one pass, which in normal times really should be the way that it performs, but it didn't work out that way. And I ended up breaking one of the shoes off. So we had to repair that, and things got slowed down on that front. So we went ahead and used a conventional mulcher that really pulverizes and incorporates residues shallowly. But as you can see on this right side of this picture, when the reverse mulcher is running properly, as you can see, if the cover crop is still full of moisture and not really heading out yet, you could flail chop and reverse mulch and produce a clean seed bed in one pass with this technology. It buries the residue about 12 inches deep. So this is a very novel way to incorporate crops and cover crops with fewer passes through the field. So I just wanted to, on a side note, away from that trial, I just want to highlight that this is the technology that was used by Israel Morales Sr. while he was working as a farmer in the Salinas Valley. So he would cover crop, flail chop, and then rip all on established 80-inch beds. He would then run his mulcher over the beds one time to realize a clean seed bed, so he could direct seed leafy greens or transplant romaine, celery, or cole crops with the residue buried about 12 inches deep. And by the time the next crop's roots reached down into that zone, the residue was mostly broken down with the plethora of biological activity. So, you know, you could see over here to the right that this is flail chopped and ripped cover crop. And then right away he came and used this reverse mulcher, and then this seed bed's ready to go for planting. So this is a pretty novel piece of machinery. It comes out of Italy, and it does run in about the $120,000 price range. So it's a bit pricey, but if you really are looking into conservation tillage in an intensive vegetable operation, this is a neat piece of machinery. So back to the trial. On the same piece of ground where we had the broccoli and the spinach. So then on April 27th of 2020, we planted spinach, and the plan was to conduct a fertilizer trial with 8 3-bed treatments that were replicated 4 times across the entire 4-acre field, where previously was the cover crop. So at this pre-treatment time, the broccoli grass cover crop reported 21 parts per million of nitrate nitrogen, and the spinach legume cover crop area was at 8 parts per million. So the nitrogen from the biomass of the grass was releasing faster than the biomass from the legume cover crop, which I thought was interesting. So then this view is to highlight the fact that at 20 days after planting, no color or growth difference was observed across the entire 4 acres. And the fertilizer treatments were replicated, and at this time we didn't really see any differences between the fertilizer treatments. But then at 49 days after planting, so almost 50 days after planting, there was a significant color difference that was observed. And at this point, we pulled nitrate samples to compare where the broccoli grass cover was from where the spinach legume cover was in the 2019 cover crop trial. And if we had realized that there was going to be such a significant color difference between the 2 sides of the field, we would have monitored them as totally separate trials. But instead, we just pulled nitrates throughout the fertilizer trial from the west side of the block that had the grass dominant cover crop. Because of the influence in the different cover crops, we didn't want to skew the nitrate analysis. But yeah, looking back, we should have had 2 separate testing systems for that. Yeah, woulda, coulda, shoulda, looking back. But this little trial did tell me that it is possible to plant on established beds into crop residue that's mowed and pre-irrigated for a cover crop to be directly drilled in, reducing tillage significantly. So we wanted to carry this out again And so this year, the second spinach crop was done at the end of the summer that we had planted on this same piece of ground. But I didn't want to incorporate it and just leave bare ground to be left fallow, and it's windy down in Soledad, so we'd have a lot of soil blowing around. So we let it just dry down naturally, leaving the roots in the ground. And obviously it got really dry, and that picture on the right, those are the spinach roots. And so they're holding the ground in place. You know, if we were to have a large windstorm, it definitely is holding the ground in place. This is the residue of the old spinach crop. And this color here is purslane, but the purslane really dried down also because we didn't irrigate. So we just let everything really dry down. But then we did a pre-irrigation, thinking that the seed was going to come, but then the seed didn't come on time. And so the pre-irrigation germinated some of the weeds before we were able to get in to plant our next cover crop. But we were able to get in and plant our cover crop, but we planted a monoculture cover crop. It was 100% Merced rye. And the Merced rye germinated very well. So this is a picture. So let's see, let me go back. So we planted on October 28th, or no, I'm sorry. If you look really close, there's some Merced rye germinating. It was planted October 15th. And so this picture is November 18th, about a month later after planting. And this is pre-shark application. So shark is a broadleaf herbicide. So we were worried that the malva and shepherd's purse and stinging nettle would really outcompete the grass. So we did do a shark application, and on November 30th, this is the post-shark application. And then this picture was taken on January 18th. And I haven't looked to see how it handled the 6-inch plus rain that it just received, but I imagine that it did just fine. But after we get some dry time, we'll go in and flail chop and incorporate this to break down. Then most likely more fertilizer trials. I think ideally I would have chopped this prior to the rain because it will be most likely a while now before we can get back in with equipment. But this is part of trial work. We're trying to learn, okay, with a 6-inch rain, how soon are we going to be able to get in to chop this down? But my concern is this was already starting to head out. You can see a few heads here. And ideally, I think it's better to chop your grasses down prior to head formation to realize more of the protein content. And so, you know, I think we have learned a lot, but there's still a lot more to learn. And I just want to highlight that just because it's always been done a certain way doesn't mean it's always the right way. So we need to think outside the box when it comes to figuring out how to farm more sustainably for our soil. I think that is definitely the way of the future. So here's just an example of, you know, let's think outside the box. So here's a subclover planted at the same time as these transplant artichokes. And the idea was to smother the prevalent weeds of hairy nightshade and south thistle, which it really didn't do in the long run. But what did it do to the soil microbial community? It didn't look, I didn't look at this aspect of this trial that we did, but is this an area of expanded research? I really do think it is. And it's been shown by Eric Brennan at the USDA Research Station that using cover crops can increase your microbial diversity significantly compared to using compost alone. And when you increase your microbial diversity, you increase your soil's ability to mineralize its own nutrients and resilience. So refer to his YouTube videos. They're really entertaining and very informative. And then I think roadside ditches are an opportunity for us to incorporate native grasses and flowers that are low growing, like lupin and poppies, and maybe even non-natives like alyssum. We just need to get the shippers on board and make them realize that this is a food safety benefit, not a hazard. And it plays into the sustainability of a farming system. And where you can, incorporate a flowering habitat into your plan. It's beneficial in the sense that you're creating habitat for predatory and parasitic insects to work for you at reducing insect and mite populations. You add diversity to your farm, both below and above ground. It is a benefit, I think, all the way around. And then these are just examples of ladybird beetle eating a red aphid in romaine, a minute pirate bug eating an immature thrip on romaine also, a syrphid fly larva consuming cabbage aphid, and then in the way lower right-hand corner is a parasitic wasp mummies coming out of these aphid. So these are all biological control agents at their best, and if we create the habitat, they will come, and cover crops play a part in creating that habitat.
Gina?
Yes.
I'm
done.
You're
echoing
we are
here.
right at our end time, and I am keen to make sure we don't keep people over. So if you can just quickly wrap up, that would be great.
Okay. And so this is a wrap up to help guide you to build a sustainable farming system. And so with that, I want to say thank you for your time. And if there are any questions, I'll monitor the Q&A. So be safe and be well.
Thank you very much. And I'm sorry we didn't have time for Q&A, but I think it's super valuable to see these practical applied experimentations. And I hope that the participants here today got some things to think about as they work with growers or manage their own operations, to ponder what works and what doesn't. Anyway, thank you so much for joining us today. We have a break and then we head to the business meeting. And last reminder to please help Hussein and his team out with that survey. If you can take a minute and complete it, that would be wonderful. Thank you so much. And we'll see you back here for the meeting shortly.
It's 1 o'clock. Is everybody here?
A few are coming back still, but I think you're okay.
Okay, Sherry, do you have anything to say at this point?
No, thank you. It's going well. Thank you, all of you, for your patience.
Thank you. Well, I'm calling to order the 2021 CA-ASA business meeting. I just want to say, if I can remember everything, there is a link, and Sherry just posted it. It's a couple, well, there's some information in that link that you will need for the approval process. We'll need to approve last year's meeting minutes and also to elect our new board members. So rather than have you go digging through the proceedings and having to find a link to that and the content therein, we just created the document that you need, so you can find that in the link. And just some comments on the way the conference is going thus far. Normally, we would hold this meeting on, this would be the last thing we do at the meeting. Typically, it would be Tuesday afternoon when we hold the meeting in person, but we thought maybe we would get more attendees at the meeting if we held it on today rather than tomorrow when we have the last sessions. Although tomorrow there's some really, all the talks have been interesting, but tomorrow we've got even more, not even more, but just more interesting talks. What am I trying to say here? All the talks are interesting, and the ones tomorrow are interesting too. So I think it's worth attending. Like we said, like I said earlier, we did try to spread this out so you could, attendees could see all of the presentations, which is a good thing. So yeah, the presentations and the format and everything, Sherry and Rachel and everyone involved with program support has been really good. And you know, if there have been any problems, they've been solved almost immediately. And I think generally speaking, we couldn't be more pleased with the way things are running. I think everyone can agree on that. So the first order of business pertains to what's in the link, and I want to give you a few minutes or a couple of minutes to take a look at last year's meeting minutes. I don't know if we could put those on the screen, but you would have to scroll through them anyway, because I think there's a couple of pages. So just to take a look at those minutes, and if I can get a motion to approve. I can't see the, where is the participant bar? Okay, there it is. And I'll put that over on this screen. So if you could take a minute to look at those, and then if I could get someone to raise their hand to approve or first motion to approve the minutes. Oh, we have one person, Jeff Dahlberg. Thank you, Jeff. Do I have a second? Nicholas seconds. Nicholas Clark seconds the motion. So the previous meeting minutes are approved. Thank you, everyone. So if we could go back to the agenda and okay, good. There's the agenda. So normally, well, at this point, I wanted to do the financial report before. So action 3 should be 4 and 4 should be 3. I'm going to go through the financial report first, and then we'll do the nominations of board members. And okay, so the financial report is normally done by the treasurer, secretary treasurer, but I think starting last year, we've just had the president do it because it takes a while for to change people during the meeting. So, but in this virtual format, maybe it would have been okay, but it's all right. I have all the information we need to make that report. And I forgot to introduce myself again. For those of you who didn't catch me yesterday, I'm Eric Ellison. I'm a research agronomist with a small startup company called Plant Response. And I'm the president this year for the California chapter of ASA. Wow, see what I mean? Proactive. Everything they do is just spot on. And which reminds me too, when it comes to finances, I checked my postal mail today, and in the mailbox was a check, a sponsor check from Della Valley Labs. And I have to apologize to Nat and the group, Ben there, who they really have every year, but I just failed to include them in our.
Oops, Eric, you're getting cut
logos.
off. Eric?
I'm getting, okay, let me open my door here. Maybe that will help.
You might have to turn your video off.
I'll turn off my video. There, that'll be better. So we did get support, just to be clear, that we did get support from Della Valley Laboratories. And I just want to make that clear to everyone that they've been a perennial sponsor, and I really should have checked with them, but I guess nobody informed me that they were sponsoring. So, but we got it anyway. So they're now on the display of sponsor logos. So that's good. Thank you, Della Valley Laboratory. So regarding the financial health of CA-ASA, just to point out what our bank account is. Am I okay now, Sherry? Is my audio okay?
It seemed to have cleared up. We'll let you know if you start breaking up again.
Okay, all right. So prior to last year, our account was sitting at, this was in December 2019, our account was at, our bank account was at $33,147. And after the meeting last year, after we went through all the payments for the DoubleTree Hotel and everything, and everything cleared, we were at $32,821.38. So we actually lost about $326, but actually that's really good for us. That's break even. So through last year, when we didn't report this last year, but through last year, we were even Steven on costs and what we took in from registration. And that's really where we want to be. We have this large balance so that we can endure some costs as they come in. Like last year, I think our account went down to $8,000 or something like that before we received our registration fee. So it's nice to have, we don't want to bounce a check or anything like that for sure. And so we have some flexibility in there to, well, we decided and we changed it in our bylaws to make that a minimum of, to hold our account at $30,000. So, and this year, for sure, we will maintain our account balance with our sponsorships to support the student awards program. And with the registration that we're taking in from program support, I think actually it's embarrassing. We might make a profit this year, but we don't really see it that way. So the thing is that when we were trying to decide on the registration fees for this virtual conference, we didn't really know how many people were going to register. So we hemmed and hawed and came up with this number of $90. We thought, well, if we got half as many to register as we got last year, which paying registrants anyway, people who pay the registration fee, if we got half as many, we would at least be break even on what the charges are from program support. And as it turned out, we have about as many people register for this conference that paying registrants as we have every year. And I think we're above 150. I mean, it's probably higher than that. So actually we took in about twice as much as we need to break even on that. But I think going forward, we're going to utilize the services of program support And those extra funds will be used for that, I'm sure. But that's something that the next group, the next year's meeting group will have to decide on. But certainly we are in good shape financially. There's nothing to worry about there. And I just want to point out all the list of services that program support has provided to us. And I don't think we could have come close to this. We did, I think Karen Lowell explored another company to do this meeting. And it was something like $25,000 or something like that. And I don't think they provided nearly, or were going to provide nearly the services that program support is providing us. And nor would they have the connectivity to the academic community and just the industry in general and knowledge of that. So just some of the things that program support provided, they communicated with all of the speakers and honorees to obtain the abstracts and the slide decks. And, made sure, kept reminding speakers to get their content in. They organized the abstract book. They held practice sessions with all the speakers. They handled registration and website development and executed all of these Zoom presentations in the meeting. So good job, program support. Thank you so much again. You've really taken or made this job easy for us this year in a time of uncertainty for us, because we didn't really know how this was going to turn out, but it turned out well. Thank you. So moving on now, I think that's the financial support report. And so regarding new members, we have 3 members who are rotating off of the board, and that's Khalid Bali, Mark Cady, and Jeff Dahlberg.
Eric, do you need to have a motion to accept the financial report?
I don't know if I don't remember a precedent for that, but
okay, just checking.
We normally don't do that. And I just want to say too, we're fortunate to be able to work with program support, and not everybody gets that privilege. They're, like I said, they're not a private entity, they're not a private company, but I think it's a good thing. So we have 3 members rotating off the board, and I would like to thank those members for their 3 years of service. And Jeff, unfortunately, Jeff is retiring from the profession and will be moving to Michigan. Lucky for you, Jeff. Thank you so much. We've enjoyed your many contributions, and you've given us a lot of good speakers. You've provided names and contacts and established a lot of good sessions. Khalid, you've contributed greatly to our irrigation management sessions, and not only as a moderator and session organizer, but as a speaker. I think you have given presentations, and we hope that you will come back to give more presentations, because we need that kind of insight, and I'd like to thank you as well. Mark Cady with CDFA, he's rotating off, but has decided to join the executive committee. And so Mark will be starting, he'll remain on the board as secretary. Well, he'll be on the executive board as secretary treasurer. And that's a 4-year term. You start out as secretary, and then your first or second president, or second vice president, first vice president, and then president. Well, then you also are past president. So, wow, once you get onto the executive board, it's really hard to get away. But it's a rewarding experience, and good luck, Mark. And thank you for agreeing to serve. And so we have the executive board. Part of their function is to nominate board members for the what's called what Council of Representatives. In the bylaws and the Constitution, it's called the Council of Representative, but we just call it the governing board. So we have 3 nominees. The first is Maria Kovanen. She will be representing as an industry representative, and she is well, Dr. Maria Kovanen. She has a PhD in soil science, and you could read her bio there, so I don't need to go through all that, but she's with Vestron Corporation. I've known Maria for a few years now, having served with her on CDFA's FREP board. And I think we're glad to have Maria on the board, or would be, because she's not elected yet, right? Nobody's elected yet. Sarah Light. Sarah has served as an agronomy advisor in Sutter, Yuba, and Colusa County, and she is I believe she's a crop with cooperative extension in that area. And then Ranjit Riar, who is a professor with Fresno State University and teaches courses there. And Ranjit was nominated by Florence Cassell, and Sarah was nominated by Michelle and a couple of others. Michelle Leifendel, gosh, Michelle, I'm having trouble. Leinfelder Miles, and I nominated Maria to the board. So if we could, instead of having everybody raise their hand to elect these new board members, I would just like to know if there's anybody in opposition, because if I had everybody raise their hand, it's hard to know. I think we would get mostly hands raised, but if there's anybody in opposition to electing these members or nominees, I don't expect that anyone would, unless you really have it in for one of them, but I don't think that's the case. So I guess maybe if I could have a motion to approve the new board members.
I move to accept the slate of nominees for the new board.
Yes. Who was that? Okay, Jeff. Who motioned first? Motioned.
That was me, Jeff.
Oh, Jeff Dahlberg. Okay, Jeff.
Yeah.
Do I hear?
Motion to accept the
do I have a
slate
second?
as presented.
Okay, Nick Clark. Same guys. Okay. So the motion is approved, and the new board members have been elected. And thank you. So moving along now to number 5, the announcement of student scholarship awards. I will turn it over to Jacob Wenger.
All right. Hello, everyone. This is Jacob Wenger. I am assistant professor of entomology at Fresno State University, and I'm the chair of the scholarship committee here. And before I announce the winner, I would just like to thank our scholarship sponsor, the Western Plant Health Association. We are, as always, extremely grateful for their continued support of the CA-ASA. They make this award possible. So this year we received several excellent applications for the undergraduate scholarship, but the committee's decision in the end was unanimous. And as such, 2021 recipient of the California ASA undergraduate scholarship is Mario Lemus. Mario worked in agriculture as a field laborer when he was younger, but has only recently come to agriculture as a student after serving as a Marine and a woodland firefighter for some years after high school. After attending some plant science courses in community college, he changed his career trajectory and ultimately enrolled in the plant science department at Fresno State University. Since his enrollment at State, Mario has repeatedly demonstrated his dedication to agronomy. And this is really where the committee was impressed that he's just been so active in the community. He joined the Campus Farms Orchard crew as a student assistant. He has participated in soil research projects with Dr. Sharon Bennis. He's maintained a 4.0 GPA, and he was also accepted into the prestigious Jordan College of Agricultural Science and Technologies honors program. And so just tremendous growth in his, basically in his career, in being a student, in really finding a passion. And so Mario's interested in regenerative agriculture and in how cultural practices may be implemented to improve soil health. And this is just so in line with, honestly, so many of the talks we've heard here at this very meeting. And so we are very proud to award scholarship to him. Now, I'm not sure if we have the ability or if Mario is here, but does he have the ability to say anything?
We would have to promote him. I think he's in the audience.
He
if
is.
he's
I
here.
will. I'm sorry. I had you buried in my screens. I will promote him. Rachel. Oh, Rachel already did. Rachel, have you?
Assuming you want to say something, Mario.
Yes, Dr. Wenger, can you hear me?
Yes, I can hear you.
Yeah, first of all, I would like to thank the American Society of Agronomy and the sponsors for giving me the opportunity to apply for this scholarship. I feel very honored, and I would also like to say that I'm a proud member of the American Society of Agronomy. I would like to thank all the faculty members at Fresno State, Dr. Bennis for her letter of recommendation, and the undergraduate research project that I did with her helped me out a lot. Dr. Kassel Sharma, she's my mentor for the honors program, and Dr. Wenger, Dr. Riar, Dr. Bushevin, and just all the faculty members for the great support for us students. It's really helpful in our academic career. Thank you.
All right. Well, thank you very much, Mario. Just a pleasure to have you here. Thanks for coming on. So with that, I will pass it back to Eric, or should I just give it straight to Nick?
I just one thing to say.
Oh, sure thing.
But thank you, Jacob. And congratulations, Mario. I was just wondering if there was some way I completely forgot about the fact that I asked for this before the meeting, whether we could show Sarah. I know Ranjit's not here, but Sarah and Maria, you're here? If we could show you that people can see you.
Sorry, Eric, I did promote Sarah, but then she joined again and went into the audience, so I will find her.
Oh, okay. Like I said, I apologize. It's rather awkward of me to not remember that, but I just.
No problem, Eric. Maria is here, so I've been listening to the great meeting that you guys put together. So
okay, I'm in the.
Thank you.
Okay, here's Maria. Hello, everybody.
Oh, there you are.
Looking forward to be part of this really great group of ag professionals. So thank you, Eric, for nominating me, and I'm ready to get to work.
Thank you, and we're very lucky to have you. Thank you very much, Maria.
Hi, everybody. Thanks for the nomination and the approval. I'm really looking forward to being on the board and working with everybody, and hopefully seeing you in person at the conference next year.
Yes, we could all hope that next year we're doing this in person. We have no intentions to do another virtual conference. It's not in our plan to convert for sure. And we're all hoping for that, Sarah. Thank you very much. Thank you for agreeing to serve the board. Okay, so now we can move on to item 6, announcement of the Student Lightning Presentation Awards. Nick, go ahead.
Good afternoon, thanks. So like Jacob, I of course want to begin with making sure that we say thank you to the sponsors for this conference, as well as the all of the awards that the students received for their exceptional efforts. This year, the lightning talks were our idea of having something in lieu of the traditional poster presentations, and it was sort of our idea of making the best out of the cruddy situation of us not all being able to be together and interact. And we especially thought that it was important that we maintained one of the critical functions for student attendees and presenters, that the students have some kind of benefit from interacting with professionals. So this was the best that we could come up with. In all, we had 12 submissions of abstracts. 10 presentations made it into the competitive round. And I wanted to share really briefly some of the feedback that I've gotten from people from the judges and colleagues on the board, and then also just at large. Several have mentioned that it was very obvious that all of the students who presented yesterday had practiced a lot. It was a very different kind of competition for this conference. Several have mentioned that they felt the students demonstrated resiliency and adapted well to the situation. Given that the exceptional effort that the students had put in and out of respect for the resiliency that they've shown, we want to break with tradition and award the top placing students according to how well they performed yesterday, in spite of all the exceptional circumstances that they've been going through in the last year. Specifically, the judges, May Cullenberg, Jacob Wenger, and Gina Colfer, found that the top presentations were placed so closely that they preferred to award 5 presenters, and we quickly accepted that recommendation. And of course, the sponsorship that this chapter receives allows us to do that. So I'm going to announce the winners of the top 5 from 5th place up to 1st place. In 5th place for a prize of $125, the title Vitidilactone, an aggregation pheromone from the east attracts cucumber beetles from the west, was presented by Jasmine Ramirez Bonilla. In 4th place for a prize of $200, presenting the title Responsive Alfalfa Varieties to Saline Subsurface Drip Irrigation, How to Account for Spatial Variability in Soil Salinity in Variety Comparisons, was presented by Simarjeet Singh. Congratulations. In 3rd place for a prize of $400, the title Evaluation of Sorghum Yield and Nutritional Quality to Varying Irrigation and Nitrogen Fertilization Regimes in Comparison with Corn, was presented by Ramandeep Brar. Congratulations, Raman. In 2nd place for a prize of $500, the title The Effect of Different Crop Residues on Soil Nitrogen Turnover was presented by Suzette Turner. Congratulations, Suzette. And then finally, in 1st place for a prize of $600, the title Statewide Collaborative Needs Assessment for California Agronomy was presented by Jessica Cantor. So congratulations to all of the students who placed, and thank you to all of the students who submitted. I'm told by the judges it was an extremely difficult decision, and we're all very, very happy that you all chose to submit and present for us. So thank you very much.
Nick, we've promoted everybody who has won. If they want to just say a short, or just if you want us to pen them.
Yeah.
Suzette is not able to attend. Maybe she had a class or something.
Yeah, please. I didn't introduce you well, so please tell us where your name, your institution, and of course, if you have any brief words, we're happy to hear them.
I guess I can get started. My name is Jasmine Ramirez, and I am a second-year graduate student at UC Davis in entomology. I'm part of the Gredenberger lab with the Dr. Ian Gredenberger, the extension specialist for entomology in California, and my research is concerned with the 2 species of cucumber beetles and melons. And thank you very much for the opportunity. And I'm very excited to have placed 5th place in the competition. And thank you so much.
So hi, this is Ramandeep Brad. I'm a graduate student at Fresno State working with Dr. Florence and working with the Center for Irrigation Technology. So I did my undergrad in India, then I came for my master's at Fresno State. It's all wonderful here, and this opportunity is so wonderful. I attended it last year, and I'm so glad I got a place. Thank you. Thank you all.
Okay. Everybody, my name is Simranjeet Singh, and I am also from Fresno State doing my master's. It's my last semester, and I'm very grateful to ASA California chapter for giving us this opportunity to present our research talks, and I'm very happy that I received the award. Thank you all.
Hi, my name's Jessie Cantor, and I'm a grad student at UC Davis. And I'm very honored. Thank you all for listening, and great job to all the other presenters. And yeah, thanks to a lot of people that are on this panel right now, like Nick and Sarah and Michelle, all really helped with this project as well. So thank you.
Eric, did you want me to kick it off to the next?
I think that was it. I just wanted to make sure that it was everyone, and that everyone that was present. So very good. I did attend the student presentations yesterday, and as we were going through them, I was like, wow, this is going to be really hard to judge. And I was not envying the judges, but thank you all for a really good presentation. And I mean, for you students to come out in this pandemic time and to try to further your academic pursuits and education is really noble. And we really appreciate your participation in our meeting. And don't forget, you are a member of CA-ASA. Anyone who attends our meeting is a member. Again, thank you. So that brings us to item 7, additional discussion as requested by the membership. And I guess if there's anything, well, many of you can't say anything as attendees, that only if you're a panelist, but if you have something, a question that you want to ask, and it's in the chat. I don't see anything yet. Or is there anything in the question? There's something about a talk in the question Q&A, but nothing about the meeting. So I guess we don't have any questions or any additional discussion as requested by the membership. So I would say that in a related matter, when you receive your conference evaluation email, you could make any of your requests on how to improve the meeting And oh, we just got a text from Suzette Turner. Well, Suzette, I guess somebody could take care of you on that. And there you go. So when you're going through, when you receive your conference evaluation email, please be sure to address all the questions on there. And we would just really appreciate your input and response on that. Yeah. Okay, so item 8 is passing of the gavel to Florence, our incoming president. So I shipped the gavel. This gavel is kind of an interesting item. It's made of, I don't know, several different kinds of wood from all over the country. And there's a message inside the little box, but it's like a real live gavel that a judge would use. It looks like one. And so I had that in my possession as president, and knowing that Florence was stepping into this role, I shipped it to her. So Florence, are you out there? Is Florence here?
She is. Florence, she was. There.
Yeah, I'm here.
Oh, there's the gavel. Just got to show the gavel.
Well, yeah, since I have it already.
So Florence, I am officially passing the gavel to you. So now you get to make all the important decisions associated with this conference and with the California ASA. Things like whether to have chicken or beef for lunch, or whether to have a plated dinner or buffet, or the really big decisions that the executive committee gets to make in the day-to-day operations of running the meeting. So congratulations, Florence. I wish you well, and I'll be, what do we call it? Well, I'll be around to help or assist in any way I can. So again, congratulations and thank you.
Well, thank you very much, Eric. Yeah, I hope next year we'll do this conference in person and we can all make all these decisions. And well, thank you very much. And it has been a real pleasure working with you and serving with you on the executive committee. But I'm sure next year you'll still be helping us with the honorary, and so we'll still be serving together. So I look forward to this coming year. So now, as is our tradition, it's my turn to extend our special thanks to you, Eric, for your contribution and your dedication to the chapter. You have worked really tirelessly over the years for making all these conferences happen with all of us. And also special thanks for serving this year as our president. And as we had to transition from an in-person meeting to a virtual conference, we were met with quite a few challenges, but I think you kept us all on track. And at the end, it all came really nicely, as we have seen in the last few days. So thank you very much for your leadership. So in the same way as we have been swapping, since you emailed me the gavel and I emailed you the plaque, so maybe now it's my turn to present you with the plaque. And I want to say then, in appreciation for your many years of service and on behalf of the California chapter of the American Society of Agronomy and all of us attending today, I would like to present you with a plaque, kind of virtually, but maybe on the other hand.
I don't know if my video,
your plaque.
if you can see the plaque.
Maybe a little bit lower, there is some glare from your window. Yeah.
Oh, okay.
The other side of, yeah, the other side.
Okay.
Eric, I think it's blurring because you have blur on.
Oh, I do.
Yeah.
Let me turn off my blur. Well,
But
if I turn off
it's
my
a
blur.
nice,
Well, I'll tell you what it is. It just
Yeah.
says in appreciation, 2021 President, California Chapter of American Society of Agronomy, and it has the gavel on there, you know, a replica of the gavel. And I really like this cool ASA logo. That's the brand. I've always liked that logo. It's really a signature of our chapter. And anyway, thank you, Florence. And I
Yeah.
just want to say, if I could just say, I was originally nominated to this committee by Richard Smith. And so I want to, on the regular board, I had worked with Richard on some research projects in the Salinas Valley concerning controlled release fertilizer, and got to know Richard. And so he apparently thought I was a scientist working in industry or something. So he nominated me to the board. And then one day I was out walking my dog, or running my dog. He doesn't walk, he runs. And is my video okay? It's okay. I've got two other people in my house Zooming. My wife teaches and my daughter's in high school, and they're both Zooming at the same time right now, I think. But anyway, hopefully the video's coming through. But then I was out walking my dog one day, and Bob Hutmacher called me, and he was the president of ASA at the time, and was looking for someone to serve the executive committee, and I agreed to do that. And then I had someone ask me one time, why would someone in industry want to be on these boards and serve? And it really just comes down to someone asking you, actually, and you don't ever, I think it's a great opportunity. It's a really an honor to be asked to be on one of these committees and to be able to serve the scientific community. And for me, as a person in industry, I like to maintain that connectivity with the scientific community. So I really appreciate the opportunity. And with that, I will finish. Thank you.
Well, thank you so much, Eric. You have dedicated many hours on the board. I think you served for like 7 years, and you gave us a different perspective coming from the industry. So it has been really great working with you. So we are really grateful for your service, Eric. Thank you so much. So that concludes our business meeting, I guess. That's the last item was on our agenda. Is there any further business? If not, I will have a motion to adjourn the business meeting. Can somebody raise a hand? Okay, Jeff, thank you. I have a motion to adjourn. Can somebody second?
Nobody wants to adjourn.
No adjournment, we keep talking. Okay, Michelle, thank you. Thank you. So thank you everyone. So the meeting is now officially adjourned. So before we just leave, though, I want to say that still we have another day tomorrow. So I encourage you, all of you, to come back tomorrow for the third day and the last session of our conference. Sorry. So we have three very exciting sessions on biological inputs, soil health, and pest management. And also you can earn some DPR CEU credits for those sessions. And I think Sherry and Rachel would have all this information. Or maybe you can expand on that a little bit before we move on, so that people know that tomorrow we have those credits available.
Yes, there are credits tomorrow, Florence, and for Department of Pesticide Regulation. And they are mostly, Rachel, maybe you can correct me. Which session are they on? What time do they start? But it's outlined on the website as well.
Yeah, this is Rachel. The program begins at 8, and if you click on the agenda posted in chat, you can see each session CEUs. DPR, there's 2.5 hours of other between a couple of the sessions. There's CCA credits in several categories and cures in 2 different categories. So take a look and we'll see you tomorrow at 8.
Yeah, thank you so much, Rachel. Yeah, we have had a few questions regarding those GPR credits. So yeah, also I want to let you know, in case you can't join us tomorrow, make sure to fill out the evaluation form that we have for you. That's really helped us to organize next year's conference. If you can provide us with some feedback on some of the session, how the conference was run, and then we'll try to use those feedback and take those into consideration for next year. So thank you very much for having joined us today, and we hope to see you tomorrow. So have a good afternoon. Bye, everyone.